Shall we start?
Yes, madam.
Naushad sir, good evening, sir.
Very good evening, madam. I'm already joined at 3:50. You may start.
Okay.
I'm ready.
Okay. Okay, sir. Good evening to all. We are as research methodology and data analysis organized by IQAC-ANNAMALAI University. Today, our resource person is Dr. Naushad PP, an associate professor in School of Gandhian Thought and Development Studies, Mahatma Gandhi University, Kottayam, Kerala. He is a postgraduate in education, history, and sociology, and took his doctorate in education. He was a rank holder of MA and M.Ed programs from Calicut University, Kerala. He started his career as a school teacher and later elevated as a teacher educator in Farooq Training College, Calicut. After 12 years of experience at collegiate education, he joined as an associate professor in Mahatma Gandhi University, Kottayam, July 2018. He is presently the Director of Printing and Publishing of Mahatma Gandhi University, member University Research Advisory Committee, member Planning Board of Mahatma Gandhi University, and member IQAC of Mahatma Gandhi University. His area of specialization includes curriculum and pedagogy, education and development, alternate education, educational ideas of Gandhi, peace education, and research methodology in social sciences. 2 students completed their PhD under his guidance, and Sarah has MPhil and PhD students doing the research under his guidance. He has completed 3 research projects funded by UGC, KSH, EC, and Directorate of Minority Welfare, Government of Kerala. Sarah is a resource person of various UGC, HRDCs, SCERT Kerala, Institute of Management in Government, PMMM NMTT projects, and various other governmental and non-governmental agencies. He acted as an external expert for examinations of various universities. He has presented papers and invited lectures in more than 100 national and international seminars and conferences. He has published extensively in the form of books, book chapters, monographs, and journal articles. At present, he has more than 50 research papers in reputed journals and published 7 books on various themes of education. Sar is here to deliver a lecture on experimental and exposed factor research. On behalf of IQAC, I welcome you, sir. We are very happy to have you here for this session. Welcome you, sir. Please take the session, sir. Thank you.
Thank you very much, madam. Hope my voice is audible.
Yes, sir.
Thank you. At the outset, let me congratulate the Internal Quality Assurance Cell of ANNAMALAI University for organizing a multidisciplinary virtual short-term training program on research methodology and data analysis. I take this opportunity to congratulate the IQAC Director of ANNAMALAI University, Professor Arivuday Nambi, and the coordinators and organizing secretaries of the program. I'm very happy to be the part of this program and part of ANNAMALAI University, one among the prestigious and oldest universities in India, especially in this part of the country. As we all know, ANNAMALAI University emerged as a university during the time of our freedom struggle way back in 1928, if my knowledge is right. And I'm very happy to be the part of ANNAMALAI University as a higher graded university by National Assessment and Accreditation Council, and also a high ranking university as per the latest NIRF ranking system. And I also express my thanks for a nice introduction by the organizing secretary of the program. I am requested to talk on a topic: experimental and ex post factor research. As we all know, experimental research is a research method emanating from quantitative research paradigm, as well as research methods in science disciplines. So for better communication, let me share my slide. Can you see my presentation now?
Yes, sir.
Yes, sir. Yes, sir. Yes, sir.
Okay, thank you. As I already mentioned, experimental research is a research method emanating from quantitative research. As a beginning, as an entry to the topic, let me give you a background of quantitative as well as qualitative research. And our topic today is actually from the basic quantitative and positivistic paradigm. As we all know, research has two basic paradigms. One is quantitative and the other is qualitative. Quantitative research relies mainly on positivism, a standpoint put forward by Auguste Comte, a famous sociologist. According to positivism, a social phenomenon can be studied using scientific method, which means that we can study a social phenomenon just as a scientific phenomenon. That is the basic postulate of positivism, and hence a social inquiry will be similar to a scientific inquiry, and hence it will be highly objective, highly impersonal. The third most important feature of a research in quantitative paradigm is that it is an outsider point of view, which means that researcher is an outsider and he is not the part and parcel of the event or the problem or the question to be explored. And another most important feature of quantitative research is that the quantitative researches are generalizable. Generalizables, which means that if we conduct a study on a particular sample, on a particular context, we can generalize the same result with a similar population and to the similar context. That is one major advantage of quantitative research. And this is deductive in nature. Deductive means that we start with the hypothesis. We start with the background of the problem with the help of previous researchers, and we establish hypothesis. And we go for data from hypothesis to test the hypothesis. So hypothesis is a general statement showing the relationship between variables. And to test the hypothesis, we go for specific data. Hence, quantitative researchers are always deductive in nature. And hypothesis testing, when I go through the different topics of this particular training program, all the topics are related with quantitative research. And hypothesis testing, there are different testing techniques also introduced in this particular training program. And there are different statistical testing procedures for testing a hypothesis. This is very important and core aspect of quantitative research. And reductionism is one advantage as well as a disadvantage of this type of research methods, because we are trying to reduce every variable, everything into number, so that we can use different types of statistical techniques. And later we infer from those results. That is normally used in quantitative research. But this is a type of reductionism because all the social phenomena are reduced into number or numerical data. And another feature of quantitative research is that the context and variables are manipulated and controlled by the researcher. So controlling of variables is one important aspect of quantitative research. And as I already mentioned, researcher is an outsider in the process, and hence researchers' emotional and personal values are out of the process. And that is why quantitative researchers are always value-free. And those researchers are trying to explain what about a phenomenon. So these are basic aspects of quantitative research, the basic nature or characteristics of quantitative research. Unlike qualitative research, when we compare this with the qualitative research, we know that the basic standpoint, the philosophical position of qualitative research is phenomenology. Phenomenology is a paradigm in which we're trying to study the subjective experiences of the members of the society or subjective experiences of the individuals rather than studying a phenomenon objectively. So subjectivity will be a feature of qualitative research because we are studying subjective experiences. And of course, qualitative researchers are always, we're trying to study the topic from an insider point of view. Researcher also will be part of the event. For example, when we use the participant observation techniques, researcher also will be a participant in the observing group. The researcher is also an insider in the process. And we cannot generalize the result of a qualitative research because qualitative researches are done in a specific context, in a specific socio-cultural context. And qualitative researchers are normally inductive in nature. We never start with a hypothesis. And we go for the data. Later, we generate hypothesis if we want. That is why qualitative researchers are inductive in nature. Inductive as well as we generate hypothesis later, which is simply an opposite direction to the quantitative research. Because in quantitative research, we start with hypothesis, and to test that hypothesis, we go for data collection. But in qualitative research, we start with the data, and later we arrive at a hypothesis or a theory. And qualitative researchers are always non-manipulative in nature, because researcher never manipulate variable. Instead, researcher observe and report what or why an event occurred. And researchers' emotional and personal feelings and values are part of this type of research. That is why qualitative researchers are always value charged. And qualitative researchers trying to explain why about the phenomenon rather than what the phenomenon is. So why aspect is important, why an event occurred, why an event happened. So we search for causes in qualitative research. Instead, we explaining what about a phenomenon. But what is a question to be answered using quantitative techniques. So the latest trend, as we all know in research methodology, is that the combination of use of both quantitative and qualitative research, because both paradigm has its own strengths and weaknesses. So to compensate and concentrate, on strengths of each one and to compensate the weaknesses of each paradigm, we are trying to utilize mixed methodologies nowadays in social researches. So my intention was only to give you a background of different paradigms of research in social sciences. Our discussion today is on experimental research, which is a research method from positivistic and quantitative paradigm of research. So this is the background from which we start. Am I clear? My voice is audible. Am I clear? Can
Yes, sir.
the organizers please?
Yes, sir. Yes, sir.
Yes, okay. Okay. So let me continue. So let me start the idea of experiment with an example with a classical example from science discipline, so that we can easily transfer the knowledge to social sciences. Suppose there is a full bag of wheat seed. This is a classical example of experiment in science. And we have a bag of wheat seed. Suppose a researcher randomly divide this bag of wheat seed into two equal parts. Randomly divide, that is very important. Randomly dividing one bag of wheat seed into two equal parts. And one half is named as X and the other half is named as Y. And the two set of seeds, both set will grow under similar condition. Both set will grow under similar condition of sunlight, water, temperature or warmth, and soil types. So a researcher wants to plant the seeds of a bag of wheat seed divided into two random parts. And one is X and another is Y, and both X and Y group of seeds grow under similar condition of sunlight, water, soil, and temperature. And the researcher added fertilizer to X group of seeds. And there is no treatment. That means there is no fertilizer used with Y group of seed. No treatment for Y and a treatment for X set of seed. And what is the result? The results show that there is high yield for the group X and low yield for group Y. So this is a clear case of experiment used in science discipline where a full bag of wheat seeds are divided into two sets, and one is named as X and the other is named as Y. And two sets of seeds grow under similar condition, but only one difference for the X group, that X group is added with the fertilizer. So what is the finding of this experiment? Why there is high yield in the X group? That is because of the use of fertilizer. The cause is fertilizer and the effect is high yield. This is a simple example of a classical experiment conducted in botany or in science. Similarly, we can use experimental method in social science context also. So now we can define what is experimental research. Experimental research involves comparison of effects. See, experimental research involves comparison of effects of different treatments, comparison of effects of groups with a treatment and without a treatment or a different treatment. So in the previous example, X group of seeds received a treatment, namely fertilizer, and the Y group without a treatment, or you can give a different fertilizer already in use. So simply experimental researchers are studying cause-effect relationship about a phenomenon, cause-effect relationship. So here in this experiment in science, which is cause, which is effect? Use of fertilizer is the cause. And what is the effect? Changes in the yield of the wheat seed is the effect. So if we added a fertilizer, there is an increase in the yield of wheat seeds. So the cause is fertilizer and the effect is increase or change in the yield of a particular wheat seed. So simply experimental researchers are studying cause-effect relationship about a phenomenon. So when we talk about experimental research in social sciences, there are doubts come. How can we utilize a scientific experiment in a social context? So let me give you some examples. So these are examples in the local context. Of course, I think you are from various social science disciplines. And of course, in your discipline also, you can identify problems which can be explored using experimental method. See, experimental research in social sciences, these are some examples. See, effect of concept mapping technique on attainment in research methodology of doctoral researchers. So this is a simple experimental research. See, my presentation, you can see one specialty. All the slides consists of a diagrammatic representation using concept map. So all my slides, and the coming slides also I have designed in terms of concept maps. So I can conduct an experiment that whether this type of presentation is useful to increase students' attainment. So before starting the presentation, I can use a test. And after this presentation using concept mapping technique, I can again conduct the same test so that I can understand whether there is a change in the attainment in research methodology. So this is a simple experiment that can be conducted. So this is an experiment that can be utilized even in this context. See, another example from different discipline, effect of consumer awareness program on purchasing behavior of rural population. See, consumer awareness program is the treatment here. It is the cause here. Consumer awareness program. Suppose you are giving consumer awareness program for villagers. And after the consumer awareness program, you test the purchasing behavior of the villagers and you compare those results with a different set of villagers without this consumer awareness program. So you can compare whether there is any improvement in the consumer behavior of villagers, those who undergone consumer awareness program. And this can be Am I audible? Hello. Am I audible now?
Yes, sir. Yes, sir. Yes, sir. Yes, sir.
Okay. In between, there was actually one interruption. Okay. I think now it is okay.
Yes, sir.
Okay, let me continue. If you have any doubts in between, you may note down, and I'll give you last 5-10 minutes for interaction so that we can clear your doubts. If you have any doubts, you can note down now so that we can continue now without interruption, and later we can have discussion on your queries and doubts. Okay. Effect of concept mapping technique is an example. Another one I have already mentioned is that effect of consumer awareness program on purchasing behavior of rural population. And third one is effect of leadership training on especially in villages, village panchayats. And if you implement a leadership training program for the Kudumbashree workers, and you can compare the effect of the leadership training program with a group without undergoing leadership training program. For another example is effect of legal literacy program on legal awareness of graduate students. Suppose you are conducting a legal literacy programs. Legal literacy is an essential thing for living in a democratic society nowadays. And suppose you are using a module for legal literacy for graduate students. And you can compare the effect of this legal literacy program with that of a different group without legal literacy. And that can be utilized. And another is effect of yoga on reducing anxiety of NEET aspirants. Effect of yoga on reducing anxiety. See, yoga is sometimes used as a technique for reducing anxiety. And NEET examination nowadays, we know that we have a number of debates on conduct of NEET examination. NEET examination is a national level testing for students who are intended to join for MBBS program, and the students are under higher pressure when the examination, this entrance examination is coming. So as an experiment, you can conduct an experiment among those NEET aspirants that one group can be used as an experimental group with yoga practice of 2-3 months and the other groups without. And after a particular period, you can test the anxiety level of the students. If there is a significant decrease in the anxiety level of the students with the yoga, you can say that yoga is an effective practice for reducing anxiety. So here yoga is the cause and the change or reduction in the anxiety is the effect. So in all these examples, you can identify one cause and one effect. And the cause will be the treatment given by the researcher. That is very important in experimental research. The cause in experimental research will be the treatment given by the researcher. See, in the first example, concept mapping technique is the cause. Concept mapping technique is a technique for presentation I am using in this particular presentation. So this is the experimental treatment. Or in the next is problem effect of consumer awareness program. Consumer awareness program is the cause and purchasing behavior is the effect. And in the third example, leadership training program is the treatment, that is the cause, and organizational behavior is the effect. And in the fourth example, legal literacy program is the cause and legal awareness is the effect. And yoga is the cause in the last example, and reduction in the anxiety or change in the anxiety is the effect. So simply an experimental research is studying cause and effect relationship. Here cause will be a treatment given by the experimenter, and the effect will be the changes in the subjects as a result of treatment. So these are some of the illustrations for conducting experimental research in social sciences. So now the important aspect, another important aspect of experimental research is the idea of variables. And the idea of variable in general is very familiar thing for researchers. I don't want to explain the different types of variable, what is variable and all. But the variable used in experimental research is different because we use the idea of independent and dependent variables in experimental research. What is an independent variable? An independent variable is a variable manipulated by the researcher or a variable treated by the researcher. In the previous examples, we have seen that effect of yoga on reducing anxiety of NEET aspirants. Here, yoga is considered as the treatment variable. That treatment variable will be independent variable. So independent variable will be the causal variable or treatment variable which researcher manipulate. And what is dependent variable? Dependent variable is the variable changes as a result of independent variable or as a result of the cause or as a result of the treatment. Here in this experiment, the effect of yoga on reducing anxiety, or here reducing anxiety is the dependent variable because anxiety is reduced because of yoga treatment. So anxiety is dependent on the treatment yoga. So yoga is independent variable and anxiety is the dependent variable here. And the two other types of variables are very important in experimental research. See, the third type of variable is intervening variable. There are some other variables. Intervening variables are simply causal variables other than independent variables. So there are several other causal variables that may influence dependent variable. And researcher will be in confusion that whether this result is because of the treatment or because of the influence of intervening variables. Consider the case of the previous example, effect of yoga on reducing anxiety of students. And for example, if there is a new legislation, or if there is a change in the date of examination, or if there is a change in the syllabus of examination, or if there is a change in the pattern of examination, the student's anxiety level may be changed. But the researcher confused that the anxiety is reduced because of researcher's treatment, that is yoga. So such type of variables that can influence the result, but researcher will be in confusion. And researcher will be in a position, difficult position to identify those intervening variables also. So intervening variables are variables which can affect a dependent variable, and they are other than independent variables. And what is extraneous variable? That is also very important. Extraneous variable, the term extraneous variable is used in experimental research, that the variables that are controlled by researcher by different techniques. The intervening variables that can be controlled by the researcher. There are two types of intervening variables. One group of variables that cannot be observed and controlled, but the other group of variables that can be measured, observed, and controlled. So those variables that can be controlled by the researcher from the intervening variables are known as extraneous variable. Hope the idea is clear that intervening variables are the all variables that can affect the result. But extraneous variables are some variables from intervening variable. Those are controlled by the researcher, or those can be controlled by the researcher. Using precise measurement techniques, researcher can identify some variables that can influence the result so that he or she can control the effect of those types of variables. So extraneous variables are simply intervening variable, but those variables that can be controlled and identified by the researcher. This is simply the idea of variables in experimental research. Now comes the most crucial aspect of experimental research. There are 4 major factors of experimental research. The first factor is control. What is control? What is controlling in experimental research? Because experimental research is conducted in an artificial context where researcher control all other variables other than independent and dependent variables. And researcher control other influencing factors that can change the result. So researcher control, for example, in the previous classical experiment of science, where researcher controlled the temperature, the soil type, the water amount, everything to be given to the seeds, because everything is controlled, because change in these can affect the result. So control is the first important element of experimental research. And the second one is manipulation. Manipulation simply means that the treatment given by the experimenter, that is the changing varying levels of independent variable, is simply manipulation of variable. So manipulation variable means that manipulation of independent variable, which means that giving treatment. In the previous example, maybe concept mapping technique on the attainment. So the concept mapping, giving concept mapping treatment itself is a treatment. Or effect of yoga on reducing anxiety of students. Here, giving treatment using yoga technique is a manipulation. So experimental treatment is simply known as manipulation. Never use manipulation in a negative connotation in experimental research, because here manipulation simply means that this is experimental treatment. And third element of experimental research is observation. Observation means researcher need to observe the change before and after experiment. Using precise measurement techniques, using precise and standardized measurement techniques, researcher needs to observe the changes in the subjects. That is simply the idea of observation. And the last element is, second is manipulation and third is observation. The last element is replication, which means that researcher need to replicate the same result in the different experimental context, so that only researcher can generalize the result to other experimental settings. If you identify yoga is an effective method for reducing anxiety, you need to ensure this with a different sample, so that you can generalize the result with the entire population. That is simply the idea of replication. So these are the 4 elements of experimental, 4 crucial and essential element of experimentation, that researcher control the variables first, control the variables other than independent variables. Then manipulation of independent variable means that the researcher's treatment, and the observation simply means that observe the changes as a result of experiment. And finally, replicate the experiment in different sample set, so that researcher can generalize the result with other experimental setting. I have already mentioned that every quantitative research intends for generalization to the entire population. So for ensuring generalization, researcher needs to replicate the data with a different sample, so that the experiment will be finalized, the experiment will be completed. Now, the one crucial aspect of experimental research is controlling of extraneous variable. I have already mentioned that extraneous variables are the variables that can be controlled by the researcher. If we control extraneous variable, you can ensure your research finding is valid. So ensuring the validity of research findings, we need to control extraneous variables. Extraneous variables are variables other than independent variable, which are observed and controlled by the researcher. So how to control those variables? There are different techniques of controlling variable. One major technique of controlling variable is analysis of covariance, which is Ancova, is a major technique of controlling variable. This is a statistical technique. And I think you have in the coming sessions, you have different inferential statistical techniques. Ancova is an inferential statistical technique that can be utilized for controlling extraneous variable. So the essential thing is that we need to have a data with regard to the extraneous variable or a controlled variable. And there must be a linear correlation between this variable, linear correlation between the extraneous variable and the dependent variable, so that you can utilize Ancova as a statistical technique to control the effect of extraneous variable. What is the basis of Ancova? It simply means that you are controlling one variable, and after controlling the variable, you are testing the effectiveness of the treatment. Control. So normally in experimental research, we have two groups. So we try to compare two groups. When comparing two groups, if there is one extraneous variable influence, you identify the extraneous variable and measure the extraneous variable using standardized measurement techniques and collect data. And if you give this data as covariate, the effect of covariate will be nullified from the final data. So Ancova used to nullify the effect of covariate. Covariate means extraneous variable. So this is a statistical technique to remove the effect of extraneous variables. And another technique is, am I audible?
Yes, sir.
Okay, okay. Because my network is not stable today. I don't know why, but hope there is no disturbances. Okay, let me continue again. Matching cases. It simply means that researcher divides the subjects, the experimental subjects, into two groups. One is X and the other is Y. The X is experimental group and Y is control group. And when we assign a subject to a subject means a sample, a subject to experimental group and control group, you identify matching cases. Matching cases means suppose there are two subjects are similar in behavior, similar in other experimental status. You can assign one subject to experimental group and the other subject to control group. And this is known as matching cases method. And randomization is another technique. Randomization is very important. When we select the experimental and control group, if you select experimental and control group randomly, for example, if you are conducting an experiment in a school, or suppose 8th standard students in a school, it is very important, so that if there is a random selection, the groups will be more or less equal. That is an assumption. So randomization is another technique for controlling extraneous variable, and removing variable is one technique. Removing variable means, suppose in some cases gender may influence the result, so which means that there are differences between male and female subjects in some particular behavior. Even social and psychological variables, sometimes male and females are different. So to remove the effect of gender, you can remove the gender itself. You can conduct experiment in only one gender. You select only girls for experimentation or only boys for experimentation so that the effect of gender can be removed. So that is simply a removing variable. Removing variable here, gender is removed using only one gender for experimentation. That is one technique for controlling extraneous variable. And another one is group matching. Group matching means that you can conduct a pretest first, and based on the result of the pretest, you can identify the mean and standard deviation of the groups, different groups, mean and standard deviation. And you change the group so as to equate mean and standard deviation of the groups. So suppose if one mean in one group is higher than the mean in the other group, if you allot some higher scoring subjects to the other group, the mean will be equal. And similarly, you can equate the standard deviation also. So mean and standard deviation of groups must be equal so that the groups are equal in nature and extraneous variables are controlled. So these are different techniques for controlling extraneous variables. So as researchers, we need to identify appropriate techniques for controlling extraneous variable. And if you cannot control, if you are not controlling extraneous variable, your result will be questioned. That is very important in experimental research. Is it clear now? Hope that my voice is audible again.
Yes, sir.
Okay. Experimental validity is next most important aspect of experimental research. Experimental validity simply means that the usability of your research finding. This experimental validity can be of two types. One is internal validity and the other is external validity. What is internal validity? Internal validity simply means that the genuineness of experimental treatment. If the result, if the change in the dependent variable is because of the genuine treatment of independent variable, because of the genuine effect of independent variable, the research is internally valid. Suppose effect of yoga on reducing anxiety of NEET aspirants. If the anxiety is reduced only because of yoga practice, your research is internally valid because there is a genuine effect of the treatment. If there is a genuine effect of treatment of independent variable on dependent variable, the experimental research is internally valid. And the next is external validity. External validity means that if we repeat the same research again with a different sample and different context, if you get the same result, that will be externally valid, so that you can generalize result to other experimental settings. So external validity is generalizability of the findings to other experimental settings. You can ensure external validity using repeated measurement, repeated treatment of the same treatment in different sample context, so that you can, if you get the same result, you can ensure external validity. So internal validity and external validity are very crucial in experimental research. And there are some chance for threats for internal as well as external validity. These are some of the challenges before internal validity in an experimental research. See, first one is selection bias is a threat to internal validity. What is selection bias? Sometimes researchers select experimental group and control groups by using his own personal bias. If you use personal bias for experimental group with a better group, and control group with the lower performance in terms of the variable. So that selection bias itself may influence the result. Because even before starting the experiment, groups were different. And researcher intentionally selected better performing groups as experimental group. This is simply selection bias. And another is experimenter bias. Experimenter bias means when we give treatment to experimental group, experimenter or research assistants may give some clues, some additional things to experimental group to perform well with regard to dependent variable. This is commonly happening to get a positive result in experimental research. So this cannot be done, experimenter bias and the selection bias. And another one is experimental mortality. Experimental mortality simply means that at the beginning of the treatment, some samples in the later stage, they withdraw from the experiment. So the result will be influenced with this withdrawal of subjects from treatment. So this is simply experimental mortality. Experimental mortality means that the withdrawal of subjects from the treatment. Because researcher cannot compel a subject or a sample to continue in the experiment. So halfway, some sample are withdrawing from the procedure, from the treatment, so that it may influence the result. Another one is the problem with the instruments. In experimental research, we need to utilize standardized instruments for collecting data, standardized instruments for pre-testing, post-testing, etc. Otherwise, if the test is not standardized, it may influence the result. That is also a threat to internal validity. Sorry for the interruption. Again, testing is another reason for reducing your validity. Testing, history of testing, because in some experimental research, there will be a pre-test. Before starting the experiment, there will be a test. So that test may influence more to the experimental group than control group. So the test items may be a clue for the experimental treatment and the final testing. So testing may influence. And the history is another one. History simply means that the history of the treatment, gradually there will be a change in the subjects. And history of previous testing. And finally, maturation. Maturation means the subjects or samples psychological changes. So maybe some experiments may longer for months and years. So there will be changes in the psychological behavior of the subjects that may influence the result. So these are all some of the threats to internal validity of experiments. And when we talk about the external validity, what is external validity? I already mentioned that the external validity means that this is generalizability of the research findings to other experimental settings. If we repeat the same result to other experimental settings, you will get the same result, then it is externally valid. So there are some threats. So the first is extent of treatment verification. In some researcher, the researchers assign research assistants for giving treatment. So different research assistants may give different types of treatment because there are personal differences. For example, I am using concept mapping technique here. If a different researcher use the concept mapping technique, his concept map will be different from my concept maps. Which means that if there is no opportunity for treatment verification means that you as a researcher need to verify whether the treatment is given as per the procedure. If the treatment is given by different research assistants, there may be chances for differences in the treatment that may influence the result. So this is very important aspect in experimental research, especially when you go for external validity. And another one is interaction of selection and treatment. Selection bias I already mentioned in the internal validity part, and treatment bias. There is selection bias and treatment bias work together here as a threat to external validity. That is interaction of selection bias and treatment bias. Selection bias means researcher intentionally select better performing group as experimental group. And treatment bias means researcher giving some treatment and giving some clues to answer true for best performance. That is treatment bias, and these two can work together. That is interaction. And interaction effect of testing and treatment is another one. Testing, pre-testing, and again treatment. So researchers or the subjects may relate the items in the testing and the experimental treatment. So that can change the result. And another one is artificiality of experimental setting. Artificiality of experimental settings means if one experiment is conducted in one setting and another experiment is conducted in a different setting, all the experimental settings may be different because normally experiments are conducted in artificial settings, not in natural settings. So changes in the experimental settings may influence the result. Another one is interference of prior treatment. Maybe if you use experiment in a same group in different context, the previous treatment influence may result the later treatment. Suppose you are giving treatment in one way, in one group, and in a different context with a different treatment to the same group. So the two experiments are conducted on one single group. So the previous experiment result may influence the later experiment or the second experiment. And another aspect of experimental research is experimental designs. There are different experimental designs. Normally, there are 5 major experimental designs. So based on your topic, your research topic, and your research context, you need to select an appropriate research design in experiment. See, there are 5 experimental design. The first one is pre-experimental design. Pre-experimental design means that there is only one group. Only experimental group. There is no control group to control. So in such a situation, researcher conduct a pre-test first to know the pre-experimental status of the subjects and go for treatment. And after treatment, conduct the test again so that the researcher can compare the pre-experimental status and post-experimental status of a single group. So simply pre-experimental research is research in single group. Only experimental group is there in pre-experimental research. And second is true experimental design, in which 2 non-equal groups are experimented. Yeah, there are 2 groups. One is experimental group and the other is control group. But there is no equal groups because experimental groups and control groups are selected, but there is no randomization, there is no matching cases. That is why groups are not equal. Normally in natural situations, you cannot select random groups. We can select groups as such. In such context, the experiment will be quasi-experimental. I already mentioned that suppose in a school, there are 20 classrooms, out of which we need to select 2 classrooms. And when we select 2 classrooms, naturally there will be differences because we cannot equate human beings. And even if you select groups randomly, there are differences in the performance of members of the groups. So in such a context, if the groups are not equal and those experimental designs are quasi-experimental designs. And the third experimental design is true experimental design, which is very difficult in social science context. Because true experimental design means that experimental research is conducted among two equal groups, two similar groups in all aspects. And this will be very difficult in human context, in social context, that to equate two groups. And another experimental research design is time series design, in which researchers collect data after experiment at different time intervals. For example, researcher collect data immediately after experiment, and again after 1 week you collect the same data, and after 1 month you collect data, after 6 months you collect data, so that you can identify whether there is any change in that course of time in the effect of treatment, if there is any change in the effect of treatment in the course of time. So you are collecting data at various time intervals in time series design. And lastly, the factorial designs. If a researcher use more than one independent variable along with the treatment, you can consider some other independent variables. So if you consider more than independent variable, such type of researchers are factorial researchers. So these are 5 major designs of experiments. And let me give a brief outline of different experimental designs. See, in pre-experimental design itself, there are different techniques. See, in pre-experimental design, there is one short case study. Here, only one group, that is experimental group. So you are conducting experiment, and after that you are observing. This is one short case study. For example, now I am using a PowerPoint presentation using concept mapping technique. And after the presentation, I am using a test. And if I get a higher result, I can say that this concept mapping technique is effective. So even without conducting a pre-test, you can go with a pre-experimental design. That is known as one short case study, but this is very rarely used. And one commonly used pre-experimental design is pre-test post-test design. One group pre-test post-test design, where a researcher conducts a pre-test first on dependent variable, again go for experiment. After the experiment, the same test is repeated as post-test. So O1 is here pre-test and O2 is post-test. And you can compare O1 and O2. If there is a significant performance increase in O2, you can say that the experiment is effective. This is commonly used pre-experimental design. And there is another pre-experimental design, static group comparison design. Here actually, there is only experimental group, but there is another group only for comparison purpose. There is no treatment. One concept mapping technique. I am conducting a post-test here. And different research scholars in a different university, I'm conducting a test only. There is no treatment. And that test is compared with the test conducted on experimental group. This is, and O1 is a test conducted on an experimental group. O2 is a test conducted on a different group without a treatment. This is a pre-experimental design. So these are 3 major pre-experimental design. So based on your research topic, you can select a research design here. And in quasi-experimental design, there are 2 major types. One is pre-test, post-test, non-equivalent group. I already mentioned that quasi-experimental researchers are groups without equality, that is non-equivalent group. So here, O1 and O2 are pre-tests, and O3 and O4 are post-test. X is experimental group and C is control group. So you can compare pre-test and post-test in this case. And here another design, post-test only design. There is no pre-test. You conduct experiment, and in control group, there will be a different treatment or no treatment, and O1 for experimental group and O2 for control group as post-test. You can compare the post-tests of these 2 groups. These are the 2 popular designs used in quasi-experimental design. And this design is most popular. Here in quasi-experimental design, there is a dotted line. This dotted line indicate that 2 groups are non-equal. the experimental groups and control groups are non-equal, and hence the notation gives a dotted line. And in the third design, true experimental design, there are three major designs. True experiment, I already mentioned that the groups are equal. Groups are equal means the groups are randomized. That is why R, the notation R is given in the entire notation. See, R indicates that groups are randomly selected so that they are equal in nature. So post-test only design, then pre-test, post-test design. Here there are randomization. Then O1 and O2 are pre-test, O3 and O4 are post-test. But two groups are equal because they are randomized. And there is one different design here. This is known as Solomon 4-group design. In Solomon 4-group design, there are two experimental group and two control group. In this, one experimental group is with both pre-test and post-test, and another control group with both pre-test and control group. But for the remaining experimental group, there is only post-test. For control groups also, remaining control groups also, there is only post-test. So that you can compare the results, whether there is any influence of pre-testing. That also compared in Solomon group design, 4-group design. This is a very popular design in social sciences. And in time series design, also there are a pre-test and post-test design. In time series design, there are post-test only design. O1 and O2 is the first time. O3 and O4 may be different time. O5 and O6 after some times. See here also, here we have O1 and O2 as pre-test. But O1, O3 and O4 as the first one. Then O5 and O6, this is O6 as the second instance, and O7 and O8 as the third time interval. So at different time intervals, you can collect data. This is simply a time series design. And finally, factorial design. Factorial design is the fifth design where two independent variables, three independent variables, maybe four independent variables. If there are two independent variables, variable 1 and variable 2, there will be only one interaction effect because interaction effect of 1 and 2. If there are three independent variables, suppose 1, 2, and 3, there will be four interaction effects, which means that interaction effect of 1 and 2, interaction effect of 2 and 3, and interaction effect of 1 and 3, and interaction effect of all the three. So there will be four interaction effects if there are three independent variables. Interaction effect means the joint effect, the combined effect. And if there are four, if there are five, if there are six independent variables, and accordingly, the interaction effects also will be increased. The number of interaction effects also will be increased, so that you need to utilize higher level statistical technique in this context. If there are more than two independent variables, we normally utilize two-way ANOVA, three-way ANOVA, like that, because there are more number of variables, more number of independent variables, so that according to the levels of independent variables, the factors will be increased. And finally, the final aspect of experimental research is data analysis in experimental research. And what are the different types of data analysis techniques used in experimental research? See, the one major data analysis used in experimental research is paired sample t-test. This is also known as dependent sample t-test or correlated sample t-test. These are all same. This is used to compare characteristics in single group. Suppose you are conducting a single group design, a pre-experimental design. You want to test the pre-test and post-test score of a single group. So the score is collected from same sample. The data is collected from the same sample. So if you want to compare the different score of a same sample, we use we group paired sample t-test. And if you want to compare two groups, experimental group and control group, we use independent sample t-test. This is comparison in two groups. For example, if you want to compare the pre-test score of experimental and control group, or post-test score of experimental group and control group, we use independent sample t-test. And if you want to compare more than two groups, I already mentioned about Solomon 4-group design, where there are 4 post-test. If you want to compare 4 post-test scores, we use Anova, because there are more than 2 mean scores. Whenever there are more than 2 mean score to compare, we utilize Anova. And in which context Ancova utilize? Ancova is utilized to control extraneous variable. I already mentioned that. So these are the 4 major statistical techniques utilized in conducting experimental research. They are paired sample t-test. In paired sample t-test is utilized to compare the data of a same group before and after the treatment. And independent sample t-test is used to compare 2 groups, maybe experimental and control group, in their pre-test and post-test. And Anova is utilized when there are more than 2 groups, which means that more than 2 mean scores, 3 or 4 mean scores. You can utilize Anova. And Ancova is utilized if you want to control extraneous variables along with the comparing groups, so that Ancova will be useful. So these are the different statistical techniques utilized in experimental research. And let me illustrate one example from experimental research. See, this is a title, Effectiveness of Concept Mapping Technique, because concept mapping technique is utilized until now in my presentation. Effectiveness of Concept Mapping Technique on attainment in research methodology of doctoral candidates. Most of the participants here are doctoral candidates. So this is a simple example, experimental research. So suppose I'm using pre-experimental design, and where hypothesis, see the hypothesis, CMAP technique will be effective in acquiring knowledge in research methodology of doctoral candidates. So I am selecting 50 doctoral candidates, and tool is a transcript on CMAP. This is a PowerPoint presentation on CMAP technique and a test on experimental research. So that CMAP presentation is on experimental research. So I am designing, suppose I am designing an experimental research. So I can use the same test as pre-test and post-test test. So before starting the experiment, you can conduct the test. And after the treatment with the help of concept mapping technique, again, you can utilize the same test that will be post-test. So you can compare the same pre-test and post-test score in a single group. So the paired sample t-test will be the technique. And what is the finding? CMAP technique. Suppose my paired sample t-test is statistically significant. I can conclude that CMAP technique is effective in acquiring knowledge and research methodology of doctoral candidates. So this is the finding of the research. So experimental research is very prescriptive in nature, very clear and systematic in nature. And this is a type of textbook method of research. Textbook means you have clear guideline for conducting experimental research. You have clear guideline for stating a title. You have clear guideline for designing choosing a design, guideline for establishing hypothesis, for sampling, even for designing tools and statistical technique. You have everything is clear and prescribed in experimental research. And the last slide in this presentation is on exposed factor research. And I hope I am keeping time, because at 5:20, I will stop my presentation and I will go for your interaction and your queries. See, exposed factor research is simply a type of research where the experimenter or the researcher is not in a position to give treatment. For some variable, researcher cannot conduct an experiment or giving treatment. Suppose I am giving you an example. Effect of home violence on children education in rural families. Effect of home violence on children education in rural families. Here, home violence is a variable, independent variable. But the variable home violence cannot be manipulated and treated by the researcher. Then what researcher can do? Researcher can identify some household with home violence and some household without home violence. So researcher can compare the effect on home violence on children education with home violence and children education without home violence. So the treatment is not done by the researcher because it is already happened. So the term exposed factor itself means something is already happened because the treatment is already happened. Researcher cannot do a treatment in such a context because treatment is already happened. And researcher's task is only to compare the effect with the event and without the event. The event is already happened. Exposed factor, the term itself means that after the event, because something already happened and researcher want to compare this. I'll give you another example of exposed factor research. See, effect of 2000 or effect of COVID-19 pandemic. Effect of COVID-19 pandemic on children achievement status. See, COVID-19 is a pandemic which has happened accidentally or which has happened as a result of the spread of the virus. And researcher cannot do anything in this spread because the experiment is already happened or the event is already happened. And the researcher's task is only to measure the status of children achievement before the pandemic and after the pandemic. This is simply the idea of exposed factor research, where researcher utilize the event already happened, and researcher may either compare with the pre-event status and post-event status, or even compare this with event happened in a, if it even happened in a group, you can compare with a different group without the event happened. So that there are two types of exposed factor research. They are correlational and causal comparative. Correlational research simply means that there are two variable, independent variable and dependent variable. They are measured in terms of continuous score. For example, suppose if you want to know the relationship between students' achievement and students' anxiety level, achievement and anxiety. So achievement is measured, achievement is already measured, and anxiety is already measured, and researcher do any treatment for that. And he or she correlate between achievement and anxiety. What is the relationship between achievement and anxiety? Because both achievement and anxiety is already happened among the students. That type of researches are correlational. And you can also compare the causal comparative in the previous example of home violence, or in the example of COVID-19 pandemic. You are comparing the pre-experimental and post-experimental status, or you are comparing the even happened and without happened groups. That is simply causal comparative design. So here manipulation of variables are not possible because something already happened. Researcher cannot do a manipulation. Researcher cannot go for a manipulation here because it is already happened. The treatment is already happened by nature. Researcher's task is only to measure the variable. Here, this type of research is experimental research. There are several contexts of exposed factor research in social sciences. Sometimes there are more chance for exposed factor research than experimental research in social sciences. But only difference is that in an experiment, in exposed factor research, there is no treatment. All other procedures are same. You can compare the result. You can compare the groups. But there is no experimental treatment and there is no control treatment because treatments are already happened. Normally this is happening in our social context. This is simply the idea of exposed factor research. So that's all about my presentation on, this is a short presentation on experimental and exposed factor research. And thank you all for patient listening. Now this is time for your interaction and your queries and all.
The participant can post your question in the chat box.
Okay, that will be better if participants type their question in the chat box. So without much disturbances, we can answer the question. That will be better. So we have 10 minutes remaining. So these 10 minutes we can utilize for experimental research. In every subject, actually, we can conduct experiments. And I already mentioned that experimental researches are prescriptive in nature. I have already given about different designs, pre-experimental or quasi-experimental, true experimental, and so on. So based on this design, you can design your experiment, and everything will be then prescriptive. So the design will be very clear. So if you use a particular design, so what will be the hypothesis, what will be the statistical technique, everything is clear. That is very important thing with regard to experimental research.
Good evening, ma'am. Chat not disabled, ma'am. I mean, can't chat.
Chat, you cannot give message. Okay. 1 minute, I'll just get in touch.
Good evening, sir.
Very good evening. You can either talk or no problem.
So what is moderating variable?
Actually, moderator variable is simply in experimental research, I already mentioned that there are intervening and extraneous variable. But moderator variable is not a term utilized in experimental research, but this is utilized in other quantitative type of research. Where moderator means if we a variable considered as a moderate, as an influencing factor, as an independent variable. But there is no moderator variable in experimental research. Experimental research either intervening or extraneous. Extraneous means that those variables that can be controlled. But the idea of moderator variable is also there in quantitative research, that some variable that can influence the result, but that is not in the context of experimental research.
So you said correlation and causal under quantitative.
Yeah.
That also comes under qualitative also, isn't it, sir?
No. Here, this correlational research, as we all know, correlation itself is a statistical technique. There is linear correlation and multiple correlation techniques.
But when we talk about interrelationship, we can bring it under qualitative, like a case study on the relationship.
Okay. This is a very good question. But when we talk in terms of exposed factor research, in exposed factor research, this we use the statistical technique correlation because data is collected in interval scale. Then only you can utilize the correlational technique or technique of correlation in research. Of course, as you mentioned, correlation or relationship between two variables that can be studied using qualitative method also. But here in the case of exposed factor research, researcher need to collect quantitative data. Then only you can both X and Y. Here X is one variable and Y is other variable. Both X and Y variable is to be collected data using interval or continuous scores. And in causal comparative also, so there are two groups and the scores from the two groups are collected using quantitative techniques. So in the context of experimental and exposed factor research, you can utilize the quantitative techniques only. But in other contexts, normally, as you already mentioned, if you want to relate to the variables using narrations and descriptions, and even using in ethnographic designs, we use the term correlation. But when we talk about from the point of view of quantitative research, correlational and exposed factor researches are purely quantitative. We use correlation and T or ANOVA, T-test or ANOVA in causal comparative X and Y as two groups. And correlation, that is small r, or Pearson product moment or rank correlation can be utilized as a linear correlation techniques. Or if there are multiple variables, you can use multiple correlation techniques.
So when we design it as a correlation study, we have to also identify whether it is under quantitative or qualitative before going on to the designing.
Yes, if it is quantitative, then it is exposed factor. Otherwise, you go for other qualitative research design. There is no quantitative data there.
Okay.
So you based on the nature of variable, you need to decide whether quantitative data or qualitative data is suitable. If this is quantitative data, normally this is an exposed factor design, and that is a quantitative research. Okay.
Last query, sir.
Okay.
Is quasi-experimental similar to causal comparative? What way it is different?
Pardon me, please, one more, repeat the question.
Quasi-experimental design
Ah.
is similar to causal comparative. What way?
No. A causal comparative design is an ex post facto research where there is no treatment by the researcher. Researcher only comparing two groups. The treatment is already happened. But quasi-experiment is different because in quasi-experiment, two groups are treated by one experimental group and another control group. In experimental, treatment is given by the researcher. But the difference is that in quasi-experimental research, two groups are not equal. Because in social context, this is very difficult to equate two groups. So in such a context, we select experimental groups and control groups as such. So that will be quasi-experiment. But causal comparative is a different design where researcher collect only data, no treatment. Treatment is already happened.
So there is no grouping also is done.
Grouping means you can compare groups in causal comparative research, because I already mentioned that one research that where home violence is a variable, independent variable. So you can compare two groups. A household with home violence. Suppose you have identified 15 homes with home violence, and you can select 15 homes without home violence, so that you can change the educational performance of students from household with home violence and students from household without home violence. Here, home violence is a variable which cannot be treated by the researcher because which is already happened among families.
So as in quasi, no equal groups, no matching cases in ex post facto also, only the
Yes. When we compare the groups, they are not equal, but there is no treatment in ex post facto. But in quasi-experimental, there is treatment by the researcher, but groups are non-equal.
Thank you, sir. Thank you very much.
Very good. Okay.
Good evening, sir. Good evening, sir.
Good evening.
Good evening, sir. Thank you for the very nice session on your PowerPoint. Your presentation was purely on concept mapping. I really enjoyed this presentation because it's a very innovative way of teaching. It was very good. I would like to ask one question. This program, what you use for PowerPoint, or is it another program?
This concept mapping I have designed using a different software, namely CMAP techniques. IHMC CMAP is a different digital software, and I have designed the software and designed the concept map and converted it to PowerPoint.
PowerPoint. Okay. Can you put the name of the software in the chat box?
That is a free software. That is a free software you can download in your computer, namely IHMC CMAP tool. IHMC CMAP tool.
Okay. IHMC. Okay, sir.
You can go search in the Google. You can freely downloadable. Windows version, Linux version, and Mac version are also available.
Okay, thank you, sir. Sir, I have a question regarding the factorial design. You told about the factorial design 2 groups and 3 groups, or 3 interventions and 2 interventions.
No. Factorial designs means not with regard to the number of groups. Factorial designs means with regard to number of independent variables. For example, along with the treatment of yoga, you test the effect of previous knowledge, or you test the effect of, along with the yoga, you test the effect, the status of previous knowledge, the students' creativity and all. So these are all can be considered as independent variables, but those variables are not treated by the researcher, but they are independent variables.
Okay.
So you can identify the combined effect of these.
Okay. Sir, in your concept mapping in that slide, you put
Sorry. Your voice is not audible.
Sir, good evening, sir.
No.
Again, sir. Sorry, sir. Again, myself. I just give me one more minute. In that factorial design, in your slide, you put the outcome, or after the 2 independent variables, you put a word there. one independent. I don't remember exactly. 1 and 2 on the 1 and 3 on the other side.
Yeah.
Yeah. What is that? Can you please explain that, sir? I did not understand that.
That's a very good question. If there are two independent variables, suppose one variable is independent variable is yoga, and the other independent variable is previous knowledge of students in NEET examination or previous experience. See, yoga and previous experience can combine together to have an effect. There are independent effects, there are a joint effect.
Okay.
Suppose there is a third variable, namely creativity.
Okay.
So there will be interaction between yoga and the previous knowledge, interaction between previous knowledge and creativity, interaction between yoga and creativity. These are three. And there is combination of yoga, previous knowledge and creativity. This is the fourth combination.
Okay,
so,
okay, sir.
In such a manner, if there are more independent variables, the factors will be increased.
Increased, yes. I got it. Understood, sir. Sir, my last question. Regarding the sample size when we use a quasi-experimental or experimental design, to what extent it should be, sir, the sample size?
That is actually a small sample is enough for conducting experiments, because both for t-test and f-test, there are small sample formulas are there. Normally, if there are for some classical experiments, the sample size is 15 to 20. So 15 to 20 cases are okay for experimental and control group. Okay, sir.
Okay. Quasi-experimental, if you are conducting on social sciences in a university or college students, so sample size should be larger for both control and for the interventional group.
30 sample size itself is considered a larger sample in experimental design. No problem.
Okay. Okay.
30 will be maximum. 30 will be maximum in a group.
Okay, sir. Okay. Thank you so much, sir. Thank you.
Thank you. Thank you.
Sir, excuse me, please put the software name again in the chat box, sir. There is a question in the chat box regarding that.
Okay. I'll check the chat box. Okay.
They're asking for the software name.
Okay. How to do sampling? Can be able to find in Google. Kindly share the details of software. I'll type here. This is simply IHMC map tool. See in the chat box, this is the. So how to do sampling of students if there are less strength? I already mentioned that 15 to 20 will be enough for conducting experiment in an experimental group. If there are 15, 20, if you go through the researches done at the Western countries and the good research journals, the sample size will be 15 to 20. That will be enough, because we are using small sample formula in t-test and f-test. That will be okay.
Thank you, sir.
I think
I invite Dr. K. Pravina, ma'am, Associate Professor, to propose thanks for this session. Ma'am, please.
Good evening to all of you. I'm happy to thank today's resource person, Professor Naushad sir from Kottayam University. Sir in his lecture has differentiated between the quantitative and qualitative research, and he has taught us what is experimental research and what is mixed research, and he has given how to conduct. He has cited examples regarding the experimental research in social sciences. That is, he has given legal literacy, Kudumbashree, then consumer awareness, yoga and reducing anxiety, and he has also explained between the dependent variable, independent variable, and threw light on the intervening variables and extraneous variable. And he has listed out the factors in experimental research, and he has explained the validity, experimental validity in a nice way. He has threw light on ex facto research. Thank you, sir, very much for sharing your expertise with us. I'm sure the participants will be highly benefited. Thank you, sir, on behalf of IQAC-ANNAMALAI University.
Thank you, sir.
I also express my sincere thanks and gratitude to the organizers, especially the IQAC of ANNAMALAI University, for inviting me to have an interaction with a large number of audience. That there are more than 300 participants even at present in the virtual positions. I once again express my sincere thanks and gratitude to you all for your patient listening, and congrats for the organizers. Thank you all, and I wish you all the best. All the
Thank you,
success.
sir. Thank you, sir.
Thank you, sir. Thank you, sir. Saila, madam.
Yes, ma'am. Chaudhary sir is in line, ma'am.
Will you introduce, madam?
You please introduce, ma'am. Chaudhary sir, good evening, sir.
Good evening, madam.
Sir,
Good evening, sir.
sir.
Welcome,
Good
sir.
evening, Pravina, madam.
We are very happy to have you again, sir. On behalf of IQAC, a warm welcome to you for this session. Today you'll be handling on logistic regression. We are happy that you are always a part of this training program, sir. On behalf of IQAC, I welcome you again, sir.
Thank you very much, madam. Okay, so thank you very much. Today is my last session in this workshop. It is about logistic regression. So during the entire workshop, there are so many different topics, different methods, different techniques discussed. So this is one of the very important technique, that is a logistic regression. So basically, there are two types of statistical analysis problems in the sorry. So there are two types of, just 1 minute. Okay, so generally we have two types of quantitative analysis or qualitative analysis technique problems. The two types of problems are, one is about the hypothesis testing. That means we want to test something about the population based on the sample data, right? Like one sample t-test, two sample t-test, dependent, independent sample, Anova test. So all these are hypothesis testing problem where we have to take the decision. We have to take the decision based upon the sample data, decision about the population based upon the sample data. So we are not predicting anything. We are not forecasting any value. Just we are testing the hypothesis whether there is a difference or there is no difference, like that. Okay. So the another problem that is about the prediction. So that is why in data analysis or in statistics, this predictive analytics is playing a very, very important role. So when we have a data from some population and we want to predict some variable based on some other variables, then that technique is known as a prediction technique. So there are different prediction algorithms available. So regression is one of them, right? So in yesterday's or day before yesterday's session, there is a separate session on simple and multiple regression. So in simple and multiple regression, we try to estimate, we try to predict one continuous variable based upon some one or more independent variable. So that is about the simple. Actually, regression. So correlation and regression, these two terms comes together. So first step is we have to check whether there is a correlation, there is an interrelationship between the two or more variables. If there is a relation, then we try to find out whether it is a linear kind of relation or non-linear kind of relation. And accordingly, we try to fit a mathematical model. Actually, regression is nothing but fitting a mathematical model to the data. And using that fitted model, if it is significant, then using that fitted model, we try to predict the future value, or we try to estimate the value from the given values of the independent variables. Okay, so regression, there are different type of regression. One is a linear regression, second one is a non-linear regression, third one is a logistic regression. Okay, so these are different type of regression. Okay, so in linear regression, and logistic regression, there is a difference, right? Very minute difference is there. Now, in this session, I will discuss about the regression analysis, different type of regressions, logistic regression. What are the different types of logistic regression? Then in logistic regression, I'm going to discuss about the binary logistic regression, and with the help of some example, we try to check whether regression, what happens if we use the linear regression for the same data, and if we use a logistic regression for the same data. And then we will discuss some example about the logistic regression problem using SPSS. Okay. And the next is we will discuss about the multiple binary logistic regression, because it is not possible to cover all type of examples, all type of models during 1.5 hour session. But I will try my best to show you how we can analyze such a type of problem with the help of SPSS, that is logistic regression, binary, multiple logistic, or whether it is ordinal. We will see that. So actually, basically, this topic is slightly difficult to understand for those people who don't have the mathematical background, but still I will try to make it very simple. Okay, so regression analysis, this already you studied in the day before yesterday session. So in simple linear regression, we try to predict one continuous variable based on one predictor variable or one independent variable. So we try to find out the mathematical model y equal to fx, where y is a dependent variable, x is an independent variable, and f is a linear function of x. It is also known as a linear function of the parameters also. Okay, so that is about the simple linear regression. Now, many times when we refer different books, so the terms used for y and x, so they are little bit different or they are little bit confusing. So initially we used to use the term dependent variable for y and independent variable for x variable. Nowadays, people are using predicted for y and predictor variable for x. That means y is a dependent variable. Y depends on x. So the alternative names are predicted and a predictor variable. Y is also known as a response variable, and x is known as a explanatory variable, because x explain about the response y. Okay, or y is also known as an outcome variable, and x is also known as a covariable. Why I am discussing this? Because many times in many different books, different terms are used. So the meanings are same. Okay, ultimately the meaning and the purpose is exactly the same. Okay, now in the regression analysis, as I told you, we have a linear regression, we have a non-linear regression. Right? Linear regression means the degree of the equation, degree of that mathematical function is 1. That is known as a linear. Right? When the degree is not 1, we call it as a non-linear equation. Say, for example, we have a quadratic equation, we have a cubic equation. Right? So all these are the non-linear regression. Right? So in linear regression, the simple linear regression means one independent variable and one dependent variable. So y, the dependent variable, is a function of only one independent variable, then we call it as a simple linear regression. So we have the equation of this type, that y equal to beta 0 plus beta 1 into x plus epsilon, where beta 0 and beta 1 are the coefficients which we have to determine by the method of least square, and epsilon is the error term. Right? Epsilon is the error terms having certain assumptions. Okay, in multiple regression, we extend this simple linear regression. Right? Instead of a single independent variable, if y depends on x1, x2, and so on, say for example, there are k variables. Okay, suppose there are k variables, right? So y depends on k variables, then we call it as a multiple linear regression, right? So this is And the interesting thing is here, now try to understand the difference between regression, linear regression and logistic regression. In linear regression, your dependent variable is always a continuous variable. Y is always a continuous. Continuous in the sense, it is a quantitative variable, either interval or ratio type variable. Okay, but the independent variable, that is all these xi's, they may be continuous or they may be categorical. Continuous means either interval or scale, or even these x1, x2, xk may be nominal or ordinal also. You can use as a dummy variable. Okay, so this is all about the linear regression, simple and multiple. Okay, now remember here what we are using. We are using x variable to predict the y variable. After fitting this model, we get the estimates of beta 0 and beta 1, and then using that equation, given the value of x, we can predict the value of y. From the multiple, given the value of x1, x2 and xk, we can predict the value of y. That means we are predicting the actual value of the variable. Okay, now in logistic regression, so try to understand first of all when we use a logistic regression. So in logistic regression, there are also two types: simple logistic regression and multiple logistic regression. The concept is same for simple and multiple. When only one independent variable, we call it as a simple. When more than one independent variable, we call it as a multiple. Okay, now what about the logistic? In logistic regression, the y variable, that is a dependent variable, is not a continuous variable. It is always a categorical variable. Categorical means either y may be nominal or y may be ordinal, right? Y may be nominal or y may be ordinal. So it is a categorical variable, right? And the x1, x2, xk, all the independent variables, either the independent variables are continuous type or they may be categorical type. So if you compare this slide and this slide, so what is the difference? The difference is only this: the dependent variable is continuous for a simple and multiple linear regression, and dependent variable is categorical for simple and multiple logistic regression, right? Simple and multiple, I hope you understand. Simple means only one independent, multiple means more than one independent variable. Okay, so this is the major difference between the two techniques. Okay, okay, now another important difference is in simple linear regression or in multiple linear regression, we try to predict the actual value of the variable, which is continuous, right? Here we are not predicting the value of the variable, but we are predicting the probability, right? Why? Because in logistic regression, the dependent variable is categorical in the sense, say for example, success or failure, yes or no, right? So if like that, right? So if we have that type of data, right? Say for example, the admission status of a student, right? Either the student get admission, that means admitted, or not admitted. Now in this case, when we have a categorical data, we always label them by 0 and 1. 0 for not admitted, 1 for admitted, right? So we have, if we have two categories, right? If we may have more than two categories also, we will see that also, right? So here in simple logistic regression, we try to estimate this probability P, right? And that probability is what? So predict, that is the probability that the y variable takes value 1 given the independent variable x. It is somewhat mathematical, but if you understand the logic, rest of the part is very simple. Okay, so we try to predict the probability that y equal to 1. That means, say for example, admitted, the status of the student is admitted given that their scores about, say for example, GRE score, GPA, grade point average, GPA score, and so on, right? So this x are the independent variable. So given the independent variable, what is the probability that the admission status is admitted, or what is the probability that the admission status is not admitted, right? Or the same can also be written in terms of the logarithm, right? We will discuss this. What is this p upon 1 minus p, right? Now this is just to compare. This is just to compare or convert the logistic type problem to a linear type problem. So when we convert this p as a p upon 1 minus p, right? This is known as a odds, right? And then logarithm of that is equal to some linear function. So ultimately, this becomes a linear function. So here we try to predict the probability, right? Now, same concept. If we consider more than one independent variable, right? So P is a probability that the variable Y takes value 1. That means the admission status is admitted given some number of independent variables. Okay. Same way, if you convert that to the odds and logarithm of the odds, then it can be written as, if you forget about the left hand side, hello, someone mic is on. Okay, if you forget about
Sir, please unmute, sir. Please unmute yourself.
Okay, so
yes, sir.
If you want to predict the value of this y equal to 1, right? That means admission status given the values of x1, x2, xk, right? So in this case, actually this log of p upon 1 minus p. So this is taken as suppose some new variable y dash. So it becomes a multiple linear regression, but we have to handle it in a different way. So this is the major difference between the linear regression and a logistic regression, right? Again, I repeat, in linear regression, because this is a very, very important concept, right? So in linear regression, the dependent variable is always a continuous variable or quantitative variable, either interval or scale. Okay. In logistic regression, your dependent variable is always a categorical variable. Categorical means either nominal or ordinal, right? Again, in nominal and in ordinal, we may have either two categories or more than two categories. So we will discuss that also, right? But try to understand, because this is somewhat theoretical part, but unless you understand the theory, otherwise what happens if you have a data, you directly give the data to the software that gives you the output, but you should know what is p and what is p upon 1 minus p. Then only you can interpret the result. So that is why this basic is important. Okay. Now, as I told you, linear regression serves to predict a continuous y variable. Okay. It is used to predict a continuous y variable, whereas logistic regression is used for binary, right? That is a dichotomous or multinomial, right? That is known as a polychotomous, right? Either dichotomous means only divided into two categories: admitted, not admitted, right? Deceased, not deceased. Okay, like that. If we have more than two categories, so we can go for a multinomial also, right? So that is known as a binary logistic regression, right? So, and the crucial limitation. Now, what happens? I will show you with the help of example also. What happens if I have a dichotomous or binary data and I feed a linear regression model to the binary data? So what is the difficulty? Why separate technique is needed? Okay, so crucial limitation is linear regression is that it cannot deal with a dichotomous or categorical data. So in linear regression, if we use dichotomous and categorical as a dependent variable, so the results are not up to the level and it is very difficult to interpret. Okay, so that is why a separate technique is needed. Okay, now in logistic regression, the technique is known as either it is a regression technique, or in terms of today's terminology, that is what we call it as a machine learning, it is also known as a classification technique, right? So it is just classifying the individual into two categories, two or more categories based on the independent information, right? So the dependent variable is dichotomous or categorical, having more than two categories. Independent variable can be continuous or it can be a categorical data. Okay, now these are some examples. Suppose I want to predict the result of a student, whether the result will be pass or fail based upon some number of independent variables, like the attendance, number of classes attended, right? Number of marks scored in the internal test, right? So many variables you can add here. So this is just an example to understand. Okay, now similarly, if you want to predict the deceased status, whether that person is deceased or not deceased based upon some different physiological characteristics, right? Similarly, admission status, whether student get admission or not admission, no admission, based upon the scores in the exam, based upon the scores in various competitive examination, right? Similarly, the another example is online transaction, whether that online transaction is a fraudulent transaction or not non-fraudulent transaction based upon the history. Okay, so there are different independent variables, right? Similarly, today's every customer, banks are giving a credit score for the every customer, right? Whether a good credit score or a bad credit score, right? So that can be decided based upon the past history, number of transaction, number of loan sanction, number of loan taken. So many variables you can use, right? So these are some examples where we can use a logistic regression, right? Now, what are the different types of logistic regression? Right. So as I told you, in linear regression, we have two types, that is a simple linear regression and multiple linear regression. In logistic regression also we have two types. One is a binary logistic regression, simple logistic regression and multiple logistic regression. But before that, based upon the type of information that dependent variable carry, we may have that we can classify this logistic regression into three categories. That is a binary, when we have only dependent variable is categorized into only two categories. Say for example, deceased or non-deceased, right? So that is only two categories. Dichotomous classification, right? But when we have more than two categorization, right, then in that case we can go for multinomial logistic regression, right? Multinomial logistic regression, right? And binary and multinomial, these two are used for the nominal type of data. If your data is nominal, now you know the difference between the nominal and ordinal type data, right? In nominal data, we just categorize, right? In ordinal data, we categorize as well as the order is also important, right? So in that case, if you have ordinal type of a dependent variable, right, whether it is a binary or whether it is multi, that means more than either two categories or more than two categories. So when the dependent variable is of ordinal type, we can go for ordinal logistic regression. So in logistic regression, there are three types of logistic regression. I repeat again: binary, when we have a nominal with only two categories; nominal with more than two categories, we can go for multinomial. Then if it is not nominal, categorical, but not nominal, but ordinal type data, then we can go for ordinal, right? And in each case, in all these three, in each case, if the independent variable is only one, we have a simple binary logistic or simple multinomial logistic, right? Or simple ordinal logistic, right? If we have more than one independent variable, then we can call it as a multiple binary logistic or multiple multinomial logistic or multiple ordinal logistic. Okay, so these are the different type of logistic regression, right? Now let us see with the help of example. Okay, so as I told you, the logistic regression.
Sir, please.
Yeah.
Okay, sir. Okay, sir.
So logistic regression predicts, it is not predicting the value. Okay, it is not predicting the value of the y variable, right? Because when you have a nominal data, your variable takes only two values, either 0 or 1, right? Say for example, admitted or not admitted. So it takes 0 or 1, right? So it is not predicting the value 0 and 1, but it is predicting the probability of occurrence of an event, right? Probability of occurrence of an event by fitting a data to a Logit function. I will show you what is this Logit function. Okay. Now, binary logistic. The dependent variable is dichotomous, that you know, right? Now, what are the examples? So, result of a student, either pass or fail. So, it may depend on number of hours of study, number of classes attended, and coaching, whether student join the coaching classes or not. Okay, so you can add as many depending upon the prior information, right? That okay, so depending upon the prior information, prior knowledge, we can select the independent variables. And as you know that with the help of software, if some variable is selected, if some variable is included in the study, but if it is not significant, so we can eliminate that variable during the analysis anytime. Okay, so similarly, another example is coronary heart disease status, whether that person, right, whether that person is deceased or not deceased is based upon the age or blood pressure or some other characteristics, right? So these are the example. Similarly, bank credit score, good or bad, it depends on age, income, payment history, length of the credit history, and so on. So you can add as many as you want, right? Similarly, loan status, whether the customer is a defaulter or non-defaulter, no defaulter, right? That depends upon age of the customer, income of the customer, home ownership, and so many factors, right? So these are the examples where we can use a binary logistic regression, right? The most important thing is this, right? Your dependent variable is a dichotomous in nature, having only two mutually exclusive categories. Okay, now in multinomial, right? So as you know now, the dependent variable is polychotomous, right? Polychotomous means with more than two categories, right? Say for example, choice of ice cream, right? Choice of ice cream flavor. So someone like vanilla, someone like butterscotch, someone like chocolate, right? And all these flavors, the choice of the ice cream flavor depends on some independent variables, like what is the occasion, what is the age of the respondent, what is the gender of the respondent, right? So that may be possible. So we can use this as an example to understand multinomial logistic regression, right? Similarly, type of movies, comedy, action, or fiction movies, that depends upon, again, gender, age, education, and so on, right? So these are the examples of a multinomial logistic regression. Now let us move to the ordinal, right? Again, as I told you, it is again a categorical data, but dependent variable can have three or more, but ordered categories, not nominal. If it is nominal, you can use earlier method, right? Binary or multinomial, right? But if it is not nominal, specifically we have to use the ordinal logistic regression. Okay, say for example, suppose the government proposed the new tax policy, right? Now, do you agree with that? If we conduct a survey and collect the data, right, about the agreement status of the individuals for the tax policy, that is agree, neutral, or disagree, it is based upon, it depends on gender, employment status, income, education, even political affiliation, right? So you can add as many. So this is the example where we can go for the ordinal logistic regression. Another example which we came across regularly, that is a grade of the students, right? So grade, that is first class, second class, pass class, or fail, or even we can include first class with the distinction, right? And that depends upon the number of hours of study, number of classes attended, whether attended the coaching classes or not, right? So many factors, education of the parents, right? So you can add as many as depending upon the prior information, right? Depending upon the prior information. Okay, so this is about the ordinal logistic regression, right? Now in this session I want to discuss this binary. So let us focus. The assumptions are more or less same for other type also, right? So this assumption, so outcome is a binary or dichotomous, yes, no, positive, negative, 1 versus 0, or admitted versus not admitted. These are the examples, right? So a linear relationship exists between the logit of the outcome. Now try to understand this logit function, right? So logit function I will explain you in the coming slide, right? But this logit function is known as a logit function, log of the ratio p upon 1 minus p, right? So try to understand this, because this is the most important part in the logistic regression. Here this p is the probability of the outcome, right? So for example, probability that the status of the student is admitted given some GRE score or GPA score, right? So that is the probability, right? And this 1 minus p, that is complementary probability, not admitted, probability of not admitted, right? And the ratio p upon 1 minus p, that is known as a odds. Okay, that is known as a odds, right? I will show you in the next slide. And if you take the logarithm of that, then that is known as a logit function. So this function is known as a logit function, right? And the other assumptions are no influential values, that means outliers. If there are outliers, so we have to remove the outliers by applying any techniques, right? Or we have to modify the data, right? So that is the no influential values, right? Again, no high intercorrelation among the predictor. Now try to understand. Predictor means independent variable. If there is only one independent variable, like a simple case, right? So in that case, there is no question of multicollinearity, right? But if we have y depends on x1, x2, x3. So x1, x2, x3, if they are intercorrelated, then that is known as a multicollinearity, right? So no high intercorrelation, no multicollinearity exist among the predictors. So these are the assumptions for the binary logistic regression, right? And same type of assumptions are for multinomial, and same for ordinary logistic regression, right? Now try to understand, because this theory is very, very important. Otherwise, directly you get the output, but it is very difficult to understand the output, right? Because the output is not straightforward, whether it is in SPSS or whether it is in R program. Okay, suppose there are two outcomes probability space, right? Say for example, deceased and non-deceased, right? So probability that an individual is deceased, so that probability is P. Okay, and probability that the individual is not deceased, that is 1 minus P. So that is the complementary probability, because we have only two categories, deceased and not deceased. So total probability must be equal to 1. Okay, so this is the basic concept. Okay, now from this P and 1 minus P, we can define odds of an event. Okay, that is known as a odds. Okay, so what is that definition of odds? It is a ratio of probability of happening of the event divided by probability of not happening of the event. Okay, it will be clear from the next equation, right? Suppose I want to calculate odds for the deceased, right? So deceased is my event, right? So what is the probability of happening of the event? So that is probability of disease, and not happening means probability of not disease. So that is P upon 1 minus P. So this P upon 1 minus P is known as odds of the event disease. Exactly same way we can define odds of non-disease, that is probability of happening of the event. That means probability of not disease divided by not happening of not disease, that is probability of disease. So it is 1 minus P upon P, right? So they are reciprocal of each other, right? So this is how we can define the odds. That is known as the odds, right? Now there is an interesting relation between, as we know that odds is related to P, okay? And we know, what can you say about P and Q? So P is a probability, Q is also a probability. So its value always lies between 0 and 1, including the endpoints 0 and 1. Okay, but odds, so this odds value can be from 0 to infinity. Its value can be from 0 to infinity. Okay, so look at this. And then if you take the log of this, if you take the log of this odds, then it becomes log of P upon 1 minus P. Or if you take the logarithm of this, natural logarithm, then it becomes log of 1 minus P upon P. And that log of P upon 1 minus P, that is known as the Logit function. Okay, that is known as a Logit or log of odds. Okay, so now this is the relation, right? So standard probability. So P always lies between 0 to 1, including 0 and 1. Okay, and the value of odds always, that is P upon 1 minus P, it ranges from 0 to infinity. And if you take the logarithm of the odds, right, logarithm of the odds, or that is known as a Logit function. Okay, it is known as a Logit function. Its value ranges from minus infinity to 0. Right, so these three things are very, very important while interpreting the regression. Okay, now look at this. What is actually the, how we convert that, right? So instead of predicting the value of y, we try to predict the probability, right? P, that is probability y equal to 1 given x. So that means given the independent variable, what is the probability that the status is admitted or status is not admitted? So 1 for admitted and 0 for not admitted. Okay, so based on, now instead of estimating the probability, instead of predicting the probability, we can predict the logarithm of the odds. Okay, we can predict the logarithm of the odds. Why? That I will explain you in the coming graph, right? Because here, so logarithm of the odds. So first we know that odds is given by this equation. So take the log of that. So it is log of this, and this equation can be written as a linear equation, that is beta 0 plus beta 1 x. So which is a linear function, right? So this above function, this function is known as either log of odds or a Logit function. It is known as log odds or Logit function, right? So this is for binary. Similar concept is there for the other. Okay, now in Logit function, again the same thing I am explaining, I'm continuing, right? So look at this, log of the odds, that is log of P upon 1 minus P equal to the linear equation. So log of P upon 1 minus P equal to the linear equation. So this is known as a Logit function. Now if I use the inverse transformation, so anti-log of this, so it becomes P upon 1 minus P, and that becomes e power beta 0 plus beta 1 into x. And when I simplify, this is a mathematical simplification. When I simplify this equation for P, I get P equal to e power this expression divided by 1 plus e power the same expression. Now this particular function is known as a logistic function because this is the logistic distribution. Okay, so what it means, the last expression. So if I know the value of x, and if I estimated the value of beta 0 and beta 1, like in the linear regression. In linear regression, what we are doing? So given the x and y, given the data, we try to estimate the coefficients beta 0 and beta 1. Once you get the estimates, so put the estimates here beta 0, beta 1, and then take the value of x, it gives you the estimated probability. Okay, so it gives you the probability that y equal to 1 given the value of x. So this is how we can use it. Okay, but now this equation is nothing but there is one statistical distribution that is known as a logistic distribution, and that is why the name is logistic regression, right? Actually, in place of logistic, we have some another distribution also, but initially they use the logistic distribution. So this function is nothing but the cumulative probability function or cumulative density function of a logistic distribution. Okay, so that is why it is known as a logistic regression. Okay, it is known as a logistic regression. So this fx, this expression is nothing but fx, and that is a logistic distribution. Okay, so that is why it is logistic. Now this is the graph of the logistic PDF of logistic regression, standard logistic regression. If you can see, right, the value of x ranges from -5 to 5, not -5 to 5, but it is on the real line, right? Even though here it shows that the red line touches the axis, but it never touches the axis, right? So this is the PDF, right? And this is the CDF. CDF means this CDF, FX, capital FX. Okay, so this is represented by this. And if you look at along the y-axis, see 0 and 1. Okay, so 0 and 1, and along x-axis we have the CDF, capital FX, right? So look at this, capital FX and P, right? So given capital FX, we can calculate the probability. And what is that probability? Probability that y is 1 given x. Okay, so it means that given the value of x, we can calculate the probability. So, and the shape of the graph is S shape. That is why it is also known as a sigmoid function. It is also known as a sigmoid function. It is a S shape curve. Okay, so this is known as a sigmoid function, and its range is from 0 to 1, right? So it means that whatever the value of the logit, whatever the value of x, okay, whatever the value of x, your y value always between 0 to 1, always between 0 to 1. Okay, so it is always between 0 to 1. Okay, so now instead of the logistic regression, if we use standard normal distribution, okay, then this expression probability y equal to 1 given x, so that is represented by the CDF of a standard normal distribution. Now why we use standard normal? Because the shape of the standard normal and logistic, they are more or less same. Okay, so look at this. This is the PDF of a standard normal distribution. Again, here along x-axis we have the real line, right? And if you convert it into the CDF, so this is the CDF. Again, it has a sigmoid function, and the range of y is 0 to 1, right? 0 to 1. So such a function is known as a probit function. Try to understand the difference. So this is known as a logit function for the logistic. This is known as a probit function if we have a standard normal distribution, if we have used standard normal distribution. Okay, so this is the difference between the logit and the probit model. Okay, so this is about the logit and probit. Okay, and once we get the equation, once we get the estimates of beta 0 and beta 1, right? So estimate of this beta 0 and beta 1. So given x, we can calculate the logit function or given x, we can calculate the probit function, and from this Logit function by inverse transformation, we can calculate the probability p, and that probability p can be used to estimate or predict the value of y equal to 1 or 0 given the value of x. Okay, so this is how we can use the regression. Okay, now before we apply the logistic regression, I want to show you why logistic regression is important when we have a categorical dependent variable, right? So I am doing it very quickly because you are familiar with linear regression. Okay, so this is my data. Okay, I have a data about age of the respondent, systolic blood pressure of the respondent, and coronary heart disease status, right? Coronary heart disease status. As we know that this coronary heart disease status may depend on age, or it may depend on systolic blood pressure also. Even the systolic blood pressure depends on age. For old age people, the systolic blood pressure is very high, right? So this is the scenario. Okay, so let us fit a linear regression between age and SBP. Okay, so let us fit a linear regression. Now this is my data view. Let me show you the data. This is my data view, right? I have ID, age, SBP, and coronary heart disease status. The CSD is a nominal type of data. You can see from the measurement scale also, right? So this is a nominal type data. Okay. Okay. So this is my data view. This is my variable view. Okay. This I showed you, right? Now, when I plot the graph, that systolic blood pressure and age, right? So if you look at the data, it shows that there is a approximately linear relation. If you draw an approximate linear line, straight line passing through maximum points, right? So we can say that there is a positive correlation between age and systolic blood pressure, right? And again, if you can do that with the help of correlation, so it is very simple to do the correlation. So go to analyze, right? And then correlation, bivariate correlation. You are familiar with this in day before yesterday's session, right? So select the variables, click OK. It gives you the output like this, right? So look at this: age of woman, and in the rows 2 variable, in columns 2 variable. So 0.709 is the Pearson correlation coefficient between SBP and age, and there are 2 star just above that. Let me show you in the presentation. Look at this. Okay, it is covered by that red block. Okay, red circle. Okay, but you can see here just above 709 there are 2 star. So here it shows correlation is significant. Okay, that means there is a significant correlation between systolic blood pressure and age. Okay, so this is how, and that can also be observed from the p-value. This 000 is the p-value. Okay, so this is about the significant correlation, right? You can check the summary statistic. Now you are familiar with the exploratory data analysis also, right? Now suppose for this data I used a simple linear regression, right? I used a simple linear regression. Now you know how to use a simple linear regression. Go to analyze, regression, linear, right? Select SBP, right? Select SBP as a dependent variable and age as a independent variable, right? I'm not going into the detail, but just to show you what output you will get, right? So this is just a simple output. So this is the output. Okay, so it shows that R is 0.709, R square is 0.502. Okay, this is the Anova table, the significant value. So this also shows that the model is significant, right? That means whatever the model we have fitted, that is significant. Let me show you in the slides because it is quite big. So look at this. So this is the significant value. 0, 0, 0, right? And here it shows what is the dependent variable, what is the predictor. So, and this is the regression output, right? This is the regression output from the data. Now, this is my data. Okay, 1 minute. Let me show you. So look at this. This constant, that is the intercept, estimate of beta 0. So this is my estimate of beta 0, right? This is the slope 1.182. So this is the slope of the line and into age. That means this equation. Now, since the equation, the model is significant, right? At the same time, both the coefficients are also significant, right? See, both the coefficients. So this is the coefficient, this is the coefficient, and this is the t-test, and these are the significant p-values. So both the coefficients are significant. So it means that age of woman, the data is about woman, right? So age of woman is a significant predictor for estimating systolic blood pressure. So it means that we can use age. Based on age, we can predict the systolic blood pressure of adult woman, right? So this is the concept of linear regression. Okay, so now what happens, right? This is now in earlier example, what we have both the variables are quantitative and SBP, that is quantitative, and SBP we want to predict based on age. So it is simple that we can use a linear regression model. But take a different scenario now. Now suppose I have this coronary heart disease status depends on either age, or this CHD status depends on systolic blood pressure. Then what? Right? My dependent variable is coronary heart disease status. It has two categories, 0 for non-disease, 1 for disease. So it is a categorical data, right? So clearly I cannot use a linear regression. But suppose still if we use linear regression, then what is the difficulty that I want to show you? Okay, so this is my data as usual. Okay, now this is the data. Now if I used to predict the dichotomous variable given a continuous variable. So I want to predict CHD status based on age. Now what happens, right? So dependent variable is binary, independent variable is age. So my function looks like this, right? CHG status, either deceased or deceased or not deceased based on age. Okay, now you can check the different exploratory, this is just to explore the data whether there are outliers or not. Now you are familiar with all these exploratory data analysis with the help of numerical summaries or with the help of charts and graphs. Okay, so this is the exploratory. Now when I plot, see, when I plot this graph, so it is a scatter plot, right? Along x-axis we have continuous, along y-axis we have continuous, right? Now, but instead of this, suppose I plot like this. Along x-axis I have the continuous variable, along y-axis I have the nominal data, 0 and 1. So that is why all the points are at 1 and all the points are at 0. In between, nothing is there. Okay, so these are the diseased patients and these are the non-diseased patients, persons, women. Okay, so this is a scatter plot. Okay, now when I feed a linear regression for such a data, right? Linear regression for such a data. So go to analyze, right? Now again go to regression, linear. Now instead of predicting the systolic blood pressure, I want to predict the CHD status based upon the age. Okay, rest of the things are same. You know how to change these values. Okay, so this is my output. So it gives you the R value 0.63. It is comparatively low as a previous case, right? But still R is 0.63. So it means that there is a significant correlation, right? Here R square is 0.401, right? This is the Anova model. So it shows that the fitted model is appropriate or significant to predict the CSD status. Here also, in the coefficient, if you can check, right? So look at this. In the coefficients also, these are the coefficients. So my fitted model is according to linear technique. My fitted model is CSD status equal to constant, that is intercept, plus slope 0.020 into age of the woman. And if you look at the significance value, both values are less than 5%. So it means that the model or the coefficients are significant for predicting the CSD status, right? That means the two coefficients are not zero, right? The two coefficients, beta 0 and beta 1 estimates, they are not zero. When we say non-zero, means this independent variable can be used to predict CSD status. Okay, so this is how. Now suppose I use the equation, this fitted equation, I use that equation to predict the CSD status of woman whose age is 78. Now what happens when I put the value of age here as 78? The predicted CSD status is 1.034. Okay, it is 1.034, and we know that. Now that is why here there are two question marks, right? We know that our data CSD status takes only two values, 1 or 0, 1 for disease, 0 for non-disease. So you cannot interpret this. Okay, or if you plot the fitted line, it looks like this, right? And you can see this is a straight line. Okay, so you can extend this straight line to both the ends, right? So when we extend it upward side, so the value of CSD status is greater than 1. When we extend bottom at the bottom side, bottom level, then the value of the CSD status is less than 0. Okay, so that is why for dichotomous or binary dependent variable, we cannot use a linear regression model. This is very, very interesting and important point which I want to highlight. Okay. Okay. Now this is another thing. Now suppose, suppose instead of this, if I use logistic regression, then what happens now, and how to use the logistic regression? Okay, so look at this. I am using the same data, right? I want to predict the CSD status, which is a binary based on the age, or you can use CSD status based on SBT, right? So this is my data, right? Now this is a binary dependent variable. Independent variable is continuous, age of the respondent or age of the age of a woman. Okay, now this is again exploratory. I'm not going into the detail because that is that you know how to interpret now. Now how to fit a binary logistic regression to the data. So there are two ways actually, but I will show you the simplest way, right? Just 1 minute. I have a just 1 minute, madam. Who? Sorry, madam, some emergency call. Okay, sorry for the disturbance. Okay, so now how to fit a logistic regression model? So if you go to a regression tab, regression menu, right? So there are different. We have selected linear regression for simple as well as for multiple, right? Now, if you look at this here, there is a binary logistic regression. Okay, binary logistic regression. There is a multinomial logistic regression. Okay, there is a ordinal logic. See, the procedure is exactly same if you understand when to use which techniques, right? The rest of the part, how to do it in SPSS and how to interpret it is exactly same. Okay, the thing is only whether binary is applicable or ordinal is applicable or multinomial is applicable. That is most important. Okay, so go to regression and binary. This is one way. Okay, this is one way for logistic regression. So this is, see, here there is a section. These 4 tabs, these 4 menus are in one section. These 4 menus are in another section, and these last 3 are in another section, right? So these are for the linear, these are for the logistic, these are for the non-linear. Okay, so another way is go to analyze, okay, and then go to generalize, right, and then generalize linear model. Try to understand this. There are 2 ways, but this generalized linear model is quite complicated. Complicated in the sense, if you want higher level analysis, right, then only we can go, because in logistic regression up to this we have discussed only 2 functions. One is a Logit function and another is a probit function. Okay, so in Logit and probit we have some another distributions also. Okay, so this is how we can use. Okay, so again I repeat, analyze, then generalize linear model, and you can select generalized linear model, and from here you can feed a linear regression, you can feed the ordinal logistic, like that means Logit, ordinal probit, binary logistic, binary probit. Okay, you can fit from this, right? And if you go to different tabs, you will get idea how to select, right? So you have to select the dependent variable. Here you have to select the covariate, that means the explanatory variable, model, right? And then what type of output you want, what are the statistics you want, all that thing, right? But I am showing you a very simple way, that is regression. Then go to binary regression. Okay, select CHD status as a dependent variable. Select the CHD status as a dependent variable. Age of woman as a covariate. Okay, age of woman as a covariate, right? Now try to understand this, right? Now here there are different methods. This enter method, right, is there. Then forward logistic regression, backward logistic regression. Now try to understand this. Many times what happens, we have many independent variables. Okay, we have many, more than one independent variables, and you want to check all at once, and you want to eliminate one by one, which is not significant. So in that case, you can select the backward likelihood ratio, right? Sorry, logistic regression, right? Backward logistic regression. Backward means first SPSS will fit the model for the whole data, and then one by one it will check the non-significant variable, independent variable, and eliminate, again refit the model like that, right? In forward, it is fitting a null model, that means only with intercept, then take one variable, take another variable, and so on. But the best way is select enter method, right? Select the enter method, right? If you have independent variable instead of single continuous, if you have categorical independent variable, suppose y, that is CHD status, x1 is age, and x2 is, suppose if you have data about male and female, then x2 is suppose gender. Now gender is categorical and it is independent, so you have to click here categorical, and from this covariate you have to select a categorical covariate, right? Right now we don't have that type of data, right? Then again go to options menu, right? Select the classification plot, right? Hosmer, Lemeso, goodness of fit test, right? You can choose the case-wise summary with some limitation for the outliers, or you can choose all the cases, right? And the most important, you can choose this confidence interval for the exponent of the coefficients. Okay, and then click continue, right? Now rest of the part That is not important. When you click OK, it will give you the output. Now I will show you the output in my presentation because I cannot zoom that SPSS window. Right now in my presentation, I have mentioned all the steps. Right, go to analyze, regression, then binary logistic. Right, then select the categorical variable, that is a dependent, select covariate. If we have a categorical variable, click on this first button and select the categorical variable. Otherwise, see, add the categorical independent variables here. Okay, if you don't have, then keep it blank, just press continue. Right, then click on the save button. Okay, let me show you that also. Okay, I will show you later. So that save button, you get the output, right, in terms of the probabilities and all these things, right? And then select this classification model, Hosmer goodness of fit test, right? And then this confidence interval, right? And the cutoff value, that is by default it is 0.5, but you can change the cutoff value. I will show you, I will explain you what is the cutoff value. Okay. Okay, now this is the output. This is the first part is always a case processing summary. So I have 32 cases with no missing values. So I have full data available. Okay, another. Now what is a dependent variable and its encoding, right? So disease is coded as 1 and non-disease is coded as 0. So this is the dependent variable. Okay, another thing. Now when I used the model enter, let me show you. When I use the method, enter method here, right? So always SPSS fit a null model. Okay. What do you mean by null model? Null model means dependent variable equal to only intercept. That means beta 0. Dependent variable equal to only intercept. That is known as a null model. Okay. So this is the null model. Okay, so look at this. Initially, using the null model, okay, let me zoom this so that you get clear idea. Okay, so look at this. This is a constant. So only constant is used. So my model is CSD status. Probability of CSD status equal to 1 equal to only beta 0. Okay, and you can see the p-value is 0.387. That means the model is not significant. That means you cannot predict CSD status just without anything, without any independent variable. Okay, so this is the estimate of B0. Okay, and then these are the variables not in the equation. So whatever the variable I have selected, actually I have selected age as an independent variable. So when I use the step 0, so this is the step 0. Look at this. Step 0, right? In the step 0, SPSS will fit the null model without any independent variable. So that is why here it is mentioned that variables not in the equation, age is not in the equation. Okay, this is one thing. Okay, another thing is, now this is the fitted model. Okay, fitted null model. Okay, this is the fitted null model. Okay, so look at this. What is the fitted model? Log of p cap upon 1 minus p cap equal to beta 0. That is this, right? But since no independent variable is there, so whatever the that means for everything it is always giving me minus 0.03 minus 0.305. So such a model is of no use. It is a useless model, right? But in SPSS the procedure is from null to the higher level, right? One by one it is including the variables. Okay, so this is the first null model, right? Now the second step is, right, the next step 1, right? In the step 1 it gives you omnibus test for the model coefficients, right? That means during the step 1 whether the model coefficients are significant or not. So that is given by this omnibus test, right? Now, what is the model before that? Because it is giving in this sequence. So what is the model actually? Let me show you the model. Okay. So look at this. This is the model. Okay. So this is the model. Okay, so step 1, age, the beta 1 estimate is 0.137. Constant, the beta 0 estimate is minus 6.727, right? And if you check the significance value, both the values are less than 0.05. Okay, both the values are less than 0.05. So it means that, let me show you, look at this. This is, you can see this, right? Age, this is the coefficient. Constant, this is the coefficient. Okay, for constant, this is the coefficient. Their significant values. So it means that both the coefficients, beta 1 and beta 0, are significantly useful to predict the CSD status. They are used for the prediction of CSD status. Okay. Okay. Now, what is this omnibus test? So look at this. Omnibus test whether the model as a whole is significant. So whatever the number of independent variables included in the model, right? So whether the model is significant or not for predicting the CSD status. So here, this omnibus test. So if you check the p-value, that is 0.000, right? So it means that age have a significant effect on the coronary heart disease status. Okay, so this is very, very important step. Okay, so p-value is less than 0.05. So age have a significant effect on the coronary heart disease. Okay, so this is how we can use this omnibus test, right? Now, what is the second output? The second output is this, the model summary, right? So if you recall the simple and multiple regression, in simple and multiple regression, we have the value of R square. Okay, that R square is a coefficient of determination, which helps to determine the amount of variation explained by the independent variable about the dependent variable. So here also in logistic regression, we have two types of R square value given by two different scientists. One is Cox and Snell, and second one is Nagelkirk, right? So these are the two R square values, right? The formulas are different, their terminology techniques are different. That is why the values are different, right? But we can use this Nagelkirk's value, that is 0.521. That is 52% of the variation in the CSD status is because of the age. Okay, because of the age. This is one interpretation. Okay, so look at this. This is how we can interpret. Okay, so this is the value of R square. So 52.1% of the variability in CSD status. Actually, you cannot compare like this, right? But still, in some books, they use this terminology, right? Because CSD status is a binary outcome. Okay, that is explained by age. Okay, this is one thing. Another is there is a Hosmer-Lemesow test, and that test is nothing but goodness of fit statistics, whether the model is adequately describing the data or not. Okay, so if you observe that output, so look at this output. Okay, so look at this. This is the output. Okay, so this is the significant value, 0.628. Okay, this is the significant value. Okay, so that also we can observe from the output that look at this, the p-value is not less than, so fitted model is adequate to the data. Okay, so these are the 3 or 4 most important things about the logistic regression. Okay, so these are the coefficients, age, this is a beta 0 estimate, this is beta 1 estimate. So let me show you. So look at this. So p values are less than 0.05. So intercept is also significant and age is also significant to predict the coronary heart disease status. Okay, so this is one way. Now, how to write the model, right? Actually, that is the most important thing. right? So because these are the values of beta 0 and beta 1. Okay, these are the values of beta 0 and beta 1, and our model is not straightforward, right? So binary logistic regression model is nothing but the Logit model. Okay, we have seen earlier that log of the odds is, right? That is why it is a Logit. Log of p upon 1 minus p cap, that is equal to estimate of beta 0 plus estimate of beta 1 into age. And from this table, you can pick the values of beta 0 and beta 1 estimate and put it here. So this is the fitted model, Logit model. Okay, this is log odds model, right, for the given data. Now from this, if you want to predict the value of p, probability of y taking value 1 given the age, right? So given age, if you put the value of age here, you get one probability, one value, that is log of odds, and by inverse transformation you can find the value of p cap. Okay, so let me show you that. So look at this. This is the Logit equation, right? Now if I use the inverse transformation, right, so p upon 1 minus p cap, that is log of this, the antilog of this, that is e power this equation. Okay, so this is the e power that value, and after simplification you will get p cap equal to this expression. Okay, so this is the logistic function and this is the Logit function. Try to understand the difference. Okay, this is a Logit function, or what we call it as a log odds. Okay, and this is a logistic function. Okay, now this last one is very useful for us. Given the age, we can find out the probability. Okay, we can find out the probability, and we know that probability always lies between 0 and 1. Okay, now what is the problem when we have fitted a linear regression? The problem with the linear regression is, look at this, I am showing you that when we have fitted a linear regression, so it is like this. The value of the probability, right, the value is beyond 1, or it may be, I have shown you, it is beyond 1 or less than 0. It is either less than 0, also it may be beyond 1 or below 0 also, right? But when we fit a logistic regression, what is the reason? The reason is because we have S-shaped curve, right? Let me show you that also. S-shaped curve. This is the S-shaped curve, right? And if you look at this, its value touches, it is extended up to 1, but not touching the 1, right? This is extended up to 0, right? Y value, right? It cannot go beyond below 0 and above 1, right? It cannot go below 0 and above 1. So that is why logistic regression is appropriate when we have a categorical data or binary data. Okay, so and the difficulty is this. Look at this. In this case, when the age is 78, it gives me the CSD status as 1.034 when I am using a linear regression. But when I am using a logistic regression, okay, when I am using a logistic regression, what I am getting, so let me show you. So this is the model which I have fitted. Okay, now look at this. Suppose I want to predict what will be the status of CSD for a woman whose age is 62, right? So we have the equation P cap equal to the logistic function. P cap equal to, everything is known in the right hand side except the age. Okay, so you can put the age here. It gives you the estimated value of the log of P. Okay, look at this. Either you use this equation or this equation. What is the difference? If you use this equation, the range is from the log of odds. So range is from minus infinity to 0. I have showed you in one of the slide, right? Minus infinity to 0 because it is Logit, right? But if you use this equation, the range is between 0 and 1. Let me show you both. Okay, so look at this. So this is when I use first, that is Logit, the range is different, right? So it is 1.452. But when I use the another equation, right, the inverse transformation, it gives me 0.811, right? So for a woman whose age is 62, the status of the CSD is probability of the CSD equal to 1 is 0.81, right? Let us recall the equation. P equal to probability y equal to 1 given x. That means given age, probability that the status is 1, that is deceased, is 0.81, and this is the probability. So we can interpret it in a different way, right? That is, the woman whose age is 62 has an average 81% chances of suffering from coronary heart disease. Okay, so this is one example where we can use, we can understand the use of logistic regression, whatever the probability. So, and when the probability is greater than 5, if you observe the SPSS, in SPSS we have selected the cutoff point as 0.5. Let me show you that. Look at this. This classification cutoff is 0.5, right? Because the probability is between 0 and 1, so we have 0.5 as a cutoff. If it is above 0.5, 5.5 or above, we call it as a disease. If it is less than 0.5, we call it as a non-disease. Okay, so depending upon that, we can get the disease status also. So either you get the probability or you can get the disease status. Okay, now let me show you. Now this is, now see, when I use the logistic regression, I'm getting the output here, right? But suppose for the given data, I want to predict the corresponding status, actual status and the corresponding status. Okay, so how to do that? So see, again I repeat, I see in my data view there are only 4 variables, right? But when I use this technique, it will increase the number of variables. How? So go to regression, I'm using the same technique, binary. Okay, now in the save option you can select the probabilities, right? So for a given age, say for example first is 22, so for 22 age of a woman, according to my model, what is the probability of CSD status? Okay, or what is the logit of the CSD status? And according to the classification table, what is the membership of that particular individual having age 22? Membership means whether that individual belongs to non-disease status or disease status. See, I have selected probabilities, group member and logit. It is the same menu, that is from the save option. Other I have already showed you, right? From the save option you can select probability, group member and logit. Okay, and just click continue. Okay, and then okay, so same output. I am not interested in output now because we have discussed the output. What I want to show you, I want to show you in the data file. Look at this. I have only 4 variables. Okay, ID, age, SBP and CSD status. Right now 3 variables are added, that is saved in a data view. Okay, what are that 3 variables? You can go to variable view to get the table labels. Look at this, predicted probabilities, right? This column is a predicted probabilities. Second one is a predicted group, and these are the logit residuals, right? Errors. Okay, logit errors. So for us, these 2 columns are very, very important. Okay, so look at this. Here the predicted probability for a woman whose age is 22 is 0.021. That means it is very close to 0, right? That is why the status is non-disease. Okay, the status is non-disease. Look at this. Whenever the value is less than 0.5, it is classified into non-disease. Whenever the value is greater than or equal to 0.5, it is classified into a disease. Yes, Venugopal, what that, Venu? Any question? If you have question, you can type in the chat box.
He has made call, sir. He can ask.
Okay. So he raised the hand. Okay. Okay. Subhashini.
Sir, I had a doubt here. If we put the classification cutoff as 0.7, that means from 0.7 it will show diseased only. Is it
actually so? that cutoff point is decided by the experimenter? Okay, so this is the default cutoff value because the probability is 0 to 1. Okay, so when we say that it is above 0.5, so when it is a normal practice, when the probability is more than 0.5, so we say that the event is more likely to occur, right? When it is less than 0.5, so we call it as a less likely to occur, like that. Okay, so this is the reason.
Can we change one more question? Can we change the confidence level from 95 to 90?
Yeah, exactly. You can change the confidence level in the selection. See.
Okay, it is not default 95%.
By default, it is 95.
Okay.
Okay. So see, let me show you. It is in the options. Okay. In the options, look at this confidence interval. By default, see in SPSS, always by default level of significance is 5%. And confidence level is always 95%. These are the default values. But if user wants to change, user can change the values.
Does it have any relativity with the classification or cutoff?
No. That don't have any relativity. That depends. See, when we choose the confidence, when you choose the level of significance 5%, 1% instead of 5%, right? So it means that you need more accuracy. Right, more less chances of error. Type 1 error is less. Instead of 0.05, if you say 0.01, so you need more accuracy. Okay, so that doesn't change your. It will affect your significance of the model. Many times, what happens if your model is not significant at 1%? Sorry, 5%. Right, it is not significant at 5%. You can change the level of significance.
Okay, thank you, sir.
Okay. Okay, so this is how we can get the probabilities. Okay, so these are the probabilities, and these are the classification status. Okay, this is the classification of what we call as a predicted group. Okay, now these values depends on the choice of that cutoff value, right? So by default it is 0.5, but based upon the prior experience, prior knowledge about the experiment, investigator can select the cutoff value as per the prior information. Okay, so this is all about the classification. Okay, now another thing is, look at this. When I plot the age and the corresponding probabilities, right? And see, earlier I have showed you the graph, right? That is using SPSS. That is this kind of graph. Okay, look at this. This is the graph. Okay, this is the graph. But from this graph, if you plot a fitted line, it looks like this approximately, sigmoid function. Okay, it looks like this, right? It never touches 1. It is very close to 1. It never touches 0. It is very close to 0. Okay, so it is not crossing the boundaries of 0 to 1. Okay, it is not crossing the boundaries of 0 to 1. So you may have this type of graph. Okay, it is like this type of graph. Okay, so it means that whatever the age you select from y-axis, right, your value of p always lies between 0 and 1. In case of a linear regression, we have the value greater than 1, right? So that is not the case here. That is why this regression is very logistic regression is very important. Okay, now along with all this, once the model is appropriate, significant for your data, then the next step is confusion matrix, which is also known as a classification table. Okay, confusion matrix, or it is known as a classification table. If you look at the bottom table, right, so these are the actual status positive and negative. These are the predicted status, positive and negative. Actual means observed. Predicted means according to the logistic regression model, I am getting positive and negative. Okay, and if you look at this, it is exactly same as that type 1 and type 2 error, right? In type 1 and type 2 error table, at two places you get the correct decision, and at two places we have the possibility of error, that is type 1 and type 2. It is exactly same way. Okay, so actually it is positive and my model says that it is positive, so that is known as a true positive. Okay, so actually negative, model says that it is negative, so that is also true negative. That means here in these two cases I am that means my prediction is perfect, right? My prediction is perfect. Predicted outcome and actual outcome, they are matching, right? But when the actual it is positive, but the model says that it is negative. Let me show you in our output also. Say for example, look at this. Actually the first woman's status is non-deceased and it shows that it is non-deceased, so this is correct. But the here the 10th woman, it is a deceased status actually, but according to model it shows that it is non-deceased, right? So this type of situation. Okay, so we have false positive, we have false negative, right? So such a table is known as a confusion matrix or a classification table. So SPSS gives you that table also based upon your coding, right? Now look at this. Out of total cases, 16 cases, they are non-deceased and predicted as non-deceased. Out of total cases, there are 9 cases where the status is deceased and the model says that it is also deceased. Okay, and only these 2 cases, 3 and 5 cases, right? In 3 situations and 5, that means total 8 situations, the decision actual and the predicted, they are mismatching. Okay, so this is the percentage of correct decision, 16 divided by the total. This is 9 divided by the total, so this is the, okay, let me show you that how it is calculated. Look at this. So this particular quantity is known as a sensitivity. So these are the notations. Okay, TP, FN, FP and TN. Okay, these are the notations. Okay, so true positive, true negative, false positive and false negative, right? And based on that we can calculate sensitivity, we can calculate specificity. So this is the sensitivity of the model, specificity of the model, and the most important thing, what is the accuracy of the model? Okay, what is the accuracy of the model? So accuracy of the model can be calculated as this diagonal elements 16 plus 9 divided by the total number of cases. Okay, because 16s are correctly identified, these 9s are correctly identified, right? Divided by the total number of cases. So it gives you the accuracy, right? So 75% the model is accurate. Okay, 75% the model is accurate. Okay, so this is how we can use the binary logistic regression model. Okay, now in multiple binary logistic regression, what is the difference? It is also binary, only the difference is instead of a single independent variable, we may have more than one independent variable. Okay, so that is multinomial. So I have, suppose let me show you, let us open the another data file, that is admission data. Okay, so before that let me show you, I will finish in 5 minutes only. Okay, because it's already 7. Okay, so look at this. This is the data about the GRE score, GPA score, prestige of the institution, undergraduate institution, right? And the admission status into the graduate school, right? So dependent variable is admission status, that is admitted or not admitted. Independent variable is GRE, GPA, which are continuous, and we can use a rank also, right? We have a data like this. Look at this. These are the, this is a part of a data, right? GRE scores are there, GPA scores are there, and ranks are there. Okay, so we can use rank also, which is ordinal type data, GRE, that is continuous type data, GPA, that is also continuous type data, and the dependent variable is admission status, that is a binary. Okay, since dependent and one dependent and more than one independent variable, we can have a multiple logistic regression. Okay, so look at this. When I plot the graph for GPA and GRE score, so if you observe, the trend is like this. Okay, most of the data is focused in this particular region. So we can say that there is a positive correlation, right? This is again just to explore. There are two observations which are outlier, in one in the not admitted and another is admitted status. Okay, so this is just to explore the data. Okay, so let us see how. Let me close this data. Okay, so I will share my presentation so that you get idea. Okay, so look at this regression, right? Again, same binary we have to use, right? Admission status, right? GRE score, GPA score, right? GRE score and GPA score. You can add another covariate also if we have, right? Now rank is a categorical data, so you can add in the categorical, but for that you have to add, first of all it is here, and then you can add in the categorical, right? But actually I don't want to use that variable right now, right? Because the analysis becomes more complicated. Okay, so just to show you, so this is how we can select. Okay, so go to options, select same options, classification plot, right? Confidence interval, you can change the confidence coefficient, right? You can change the cutoff value. Okay, and then go to save option. You can save the probabilities, group member, and Logit values. Okay, so these are the only things you have to do. You can choose the method forward, backward, right? If you choose forward, so it will fit first of all the whole model, admission status on GRE and GP, then eliminate one by one. If you choose backward, so it will fit a null model and add one by one. Okay, so this is my output. Okay, so let me show you the same output in the slide so that you get clear idea. Okay, so you can choose sorry, one minute. Actually I have to choose that multi. Okay, it is okay. I have selected properly. Okay, so this is the output. If you check the step 0, right? So this is the significant value. That means constant, but it is of no use. It is meaningless when we use the only constant only, right? Then GRE and GPA, right? So GRE and GPA. Before that, we can check this model summary, right? And omnibus test. So model is appropriate for this data, right? And this R square value is 0.067, which is very low. That means some additional information is required, right? And then this Hosmer test, goodness of fit test, that is more than 5%. So that is also appropriate. That means the data is that model is appropriate for the data. Okay, so this is, look at this. These are the values, right? So this is 0.788, right? And this omnibus test, it also shows that these two independent variables have a significant effect on the admission status. Okay, and R square value, so it is very low actually. So it means some additional information is required to predict the admission status. Okay, similarly, this Hosmer goodness of fit test, it is also showing that the fitted model is adequate for the data. Okay, and then you can use the, and another is this one, individual significance. Okay, so look at this individual significance, the accuracy of the model. So actually it is less, but still it is more than 50%. Okay, so look at this. 9 are admitted and predicted as admitted. 263, they are not admitted and predicted as not admitted, right? So this percentage is low, but for not admitted, the percentage is very high. And overall, the accuracy of the model is 68%. At the same time, these are the beta 0, beta 1, beta 2 estimates. All the coefficients are significant because the values are less than 5%. Okay, then how to use that? Okay, so look at this. This is a log odds. Okay, intercept beta 0, beta 1, beta 2. So these are from the model. These are the values, beta values. Okay, these are the values. And from this, if you want to write the model, you can write a logit model. Log of p upon 1 minus p equal to intercept plus first slope into GPA plus second slope into GRE. Okay, so this is that. Okay, if you want to write a similar model for, and how to interpret that? So if we change one unit exactly in the linear regression, okay, so what is the interpretation of this minus 0.755? So if GPA score is increased or changed by 1 unit, the log of odds in admission changes by this amount, but it is quite difficult to understand, right? Because when we say log of odds, so it is very difficult, but same interpretation for this, it is very important. Okay, so look at this, how it is. So in terms of the exponent Logit function, in terms of the Logit function, let me show you. In your output, you can see B quantity in the table. Okay, this is the B quantity. Okay, let me show you here. This is the B quantity. Okay, at the same time, it gives you E power B quantity also. So these are that quantities. Okay, so these are the B quantity. Okay, so these are the B quantity. Okay, 141. Look at this. The output. Look at this. This is 141.08, 0.47, 0.997. Right. So these are the values. Okay. Now these values are very useful to interpret. Okay. So keeping now, since we have a multiple regression, multiple logistic regression, right? So if you want to interpret the coefficient for GPA, right? So in that case, keeping GRE constant, if GPA score is increased by 1 unit, then how many times it is more likely that the students is in the admitted status? So it is 0.4702 times more likely to be in the admitted status, right? Exactly same way, if you want to interpret for GRE, then in that case, keeping GPA constant, the GRE increases 1 unit, then 0.99, that means 99%, there are chances that the status will be admitted, right? So this is all about the multiple logistic regression, right? And if you want to perform the ordinal logistic regression, again, you can go to regression, ordinal, right? Say for example, ordinal. So look at this. In the dependent case, you have to select the ordinal variable, right? And in the covariate, you have to select the independent variables, right? All other things are exactly same, right? You can change the values, you can change the output, what type of output you want, like that, right? So this is all about the logistic regression in today's session, right? And suppose if you want to predict, suppose someone GPA score is 3.38 and GRE score is 588. So in the earlier equation, just put the values of GPA and GRE, you will get the value of log odds, right? So this is the value of log odds. This is the log odds value, right? Take the inverse transformation and then calculate the value of P, that is 0.65. So we can interpret this in such a way that a student with a GPA score 3.38 and GRE score 588, sorry, here there is a typing mistake, okay, has average of 65.30% chances, 65% chances that he may be getting that admission. Okay, so this is all about today's session about the logistic regression. It is quite mathematical. I hope you get idea about when to use simple linear regression, when to use logistic linear regression. Yes, Subhashini. Yes, Subhashini, madam. You can ask the.
Sir, is there any use of the null model just with the constant? I think there is any use with that.
It is of no use. Just imagine.
Then why do we calculate it then?
Actually, it is when we use the enter method, right? So in SPSS or in general, there are actually in a regression, there are stepwise regression technique. Actually, it is nothing but taking all the variables at a time, right? We try to eliminate variables one by one. Okay, so that is one technique. That is known as a full model, and from full model, we try to reduce the number of independent variables which are insignificant, right? And at the end, you will get one model. But suppose if no variable is significant, then at the end, what you will get? You will get a null model. Okay, and
just the
that
intercept.
null, yeah, only intercept, right? And that null model, logically, it is of no use, because when it is logically of no use, because when we say that what is our earlier question, that is about the systolic blood pressure. Okay, so systolic blood pressure equal to some constant, right? So you cannot interpret whatever the data is, it is always constant. And when you plot the line, for that you need two variables along x axis and along y axis for dependency. Okay, so that is just a process in SPSS or in software to consider null model and then go on adding the variable one by one to get the significant model, or full model and go on eliminating the insignificant variable to get the final model. Okay, I hope it is clear.
Can you explain once more the forward LR and the backward LR?
Okay, in the forward method, see, take a very simple example.
Null to full model?
Yeah.
So forward is starting with the null to...
No. Forward LR is from full model to the null model.
Okay.
We have, say, for example, let us take a simple scenario, right? I have this data. Okay. Now I have GRE, GPA, rank. So I have three independent variables and admission status as a dependent variable. Okay. So I can use enter method, right? Or I can use a forward method. So in that case, admission status depends on GRE, GPA, and rank. If any of the variable is insignificant, it will eliminate and refit the model on the remaining variables. So from full to null. Is it clear?
All of them are going to be significant, then we'll get the...
Then that is the final model.
Okay.
Okay.
Okay, sir. Thank you, sir. Thank you very much for the session.
Thank you.
Myself, Neisamani Sonja from Aligarh, sir. I would like to ask you a question. Sir, can we use F-test for the regression, logistic regression?
Can you repeat, madam?
Can we use the F-test?
In logistic regression?
Yes, sir.
Actually, we cannot use F-test in the logistic regression because if you check the output, let me show you the output. Okay, yes, so this is the 1 minute. Let me show you the output. Where is that output? Okay, so in the entire output for binary logistic or multiple logistic, whatever we have seen, so in almost all the cases, we have this walled test. Okay, actually this walled test for testing the significance of the predictor, it is walled is nothing but it follows a chi-square distribution. Okay, so it is chi-square. Okay, another is in omnibus test also. So this this goodness of fit test also we have a chi-square, right? So in logistic regression we never use F-test. Either we have a chi-square test, not either. It is always a chi-square test. Look at this. In omnibus all are chi-square. Okay. in this case also, in the Hosmer test also, we have a chi-square. Okay, this is one thing. Another thing is, if you go to that regression coefficients, okay, if you go to the regression coefficient table, this walled test is also a chi-square test. Okay, so in logistic regression, we never use F test, but in the linear regression, we can use the F test for the significance of the model. Is it clear?
Thank you, sir. Thank you, sir. It's clear. Thank
Okay.
you.
Yes, any one of you want to speak anything about this?
If you have any doubt, you can ask me. And if someone wants my email address, so this is my email address. Okay, so you can mail me if you have any doubt, any query, clarifications. Okay, so this is my email address. And another important thing is, this is my website, vrcbus.com. You can take a screenshot of this. It contains email and website also. This website contains statistical methods simplified with the help of illustrations, manual calculations using R programming, right? So you can refer this website for basic knowledge about statistics.
Thank you, sir. Anyone want to speak now? You can unmute yourself.
Good evening, sir.
Good evening, madam.
Sir, since elections are going on currently and opinion polls are coming, there we see margin of error. Some is saying it is not correct, some is saying it is less, more. What about, sir, the technical statistical data which they are using? Suppose Uttar Pradesh is the largest state, sir.
Yeah.
And some opposition is saying these students should be banned of 8,000 people. How can it be just that the opinion poll is correct or wrong, sir?
So actually, opinion polls are always in doubt. The reason is in today's scenario, the news media, they are just encashing the, they are just increasing the TRP. This is what I think. Okay, they are increasing their TRP with the help of different type of opinion polls. There are scams and everything also. But logically speaking, opinion poll is a kind of a technique to get idea about the future event. Like in this case, based on they go to certain places, right? Again, there is a doubt. There is a doubt whether the entire population is covered. Only few part, only educated are asked the question. So many issues are there. Okay, but the technique is there about opinion poll, right? We can conduct opinion poll to get idea about some future event. Okay, so they are also using the same technique. They move to different places, different cities. They ask certain questions, predefined questionnaire, right? And from that they analyze and they conclude that as per the opinion poll conducted on these many peoples, this party will be winning. So this is the scenario. Is it?
Yes, sir.
Is
Do
it
anyone
clear?
want to speak else?
Okay, if you want to.
Sir, what kind of tests are conducted for opinion polls, sir?
Yellow. So it depends. It depends from state to state and political affiliation. It depends from state. It varies from state to state. Again, it depends on the locality also, right? But there are certain questions which the actually when we design a questionnaire, what type of question we include that is useful for your research. Okay, so if they want information about the political parties, their affiliations, their work culture, what they did in the past, okay, so accordingly they collect the data. Okay, and then from that data, and that data is not a small data, it is a huge data. Okay, because so many different type of questions they are asking, and that question, number of question and type of question vary from state to state. Anyone? Okay, I hope,
Anyone?
madam.
Yes, sir. Anyone want to speak still?
Sir, Raju sir.
Good
evening. This is Subhashini Raman from IIT Gandhinagar, sir.
Okay.
Thank you for the whole session, all the sessions. You have explained it so well. And as researchers, data analysis is very, very important.
Yeah, definitely.
Yes, and in data analysis, if you don't infer properly, then research is of no use.
Yeah, exactly.
Actually, so you have taught us how to infer the whole data, I think. So when we do the research, I think it will be very, very helpful, sir.
Actually, in any kind of research, 2-3 things are very important. The first thing is type of data used for a particular technique, right? You cannot use any variable to any technique, right? And basically, when you don't have that knowledge, right? Many times this happens, right? They don't know how to handle the Likert scale data, and they apply for Likert scale data some t-test or something else, right?
Yes,
so in that case, your research is totally in a different, that means it is not properly, right? So selection of the variable, type of the variable, and then applying proper method, that is again important. If you want to predict something and if you are using different techniques, so that is also not proper, right? So that is very, very important.
Thank you, sir. Now we are confident about our data analysis part. Chapter 4 is very, very important, we know. So
Thank you very
much. You have
much.
taught us so well that these sessions have made us a little more confident on what we have to, what we are predicted to do.
Thank you very much.
On behalf of all the participants here, I extend my heartfelt thank you, sir, to you.
Thank you.
Thank you, Subhashini. Thank you. Pravina ma'am.
Yes, madam. Sir.
Hello, madam. Sir. Good evening, madam.
I'll say a small quote for you, sir. The meaning of life for a teacher is not being rich, being popular, being highly educated, or being perfect. It is about being real, being humble, and being strong, and being able to share the knowledge acquired among the students, which will enhance the life of their students. Such an excellent teacher who is humble and real is Professor Raju Chaudhary. Sir, on behalf of IQAC and my own behalf, thank you, sir, for the wonderful, informative, and easy to understand session, sir. Thank you once again, sir. Thanks for being with us and sharing your expertise.
Thank you very much, madam, for a nice word. Actually, I believe in one thing. If you have a knowledge, share with everyone.
Yes,
this
sir.
is my single line.
Sir. Very nice. I'm sure the participants, those who are really interested and those who are involved, will be highly benefited with all your sessions, sir. Thank you, sir, for your expertise.
Thank you. I think Deepa
Kumaravel ma'am. Do you want to speak, Deepa ma'am?
Yes, ma'am. Yes, ma'am. I want to say a few words about our today's resource person, sir, Raju, sir. Sir, one thing I have learned from you, sir, there is no limit in age for learning. So such a dedicated research person you are. So every presentation which you have made is crystal clear, sir. So from your words also, from your presentation also, it is very, very useful for us, especially this Anova and this regression session. And why this normality test, why we have to conduct this normality test and how to explore the data. So I'm also a research scholar, sir. Now only I have entered for PhD. Okay. So I have learned many things. Apart from this, I am also doing research for PhD scholars also as well. So from this, I have learned how to explore the data. So for how to use the tools for analyzing the data. So very, very thankful to you, sir, and I hope we'll have a great learning from you, and we'll have a good touch in with you for a further process also. Thank you so much.
Anytime. Thank you very much, madam, for the nice words.
Thank you, Deepa,
you can contact me anytime. You have my email address.
Sir, thank you, sir, for your patience and dedication. Your manner of teaching is so wonderful and refreshing, sir. All your sessions were very interesting, passionate, committed, inspiring, energetic, stimulating, sir. You are a sincere and dedicated teacher, and you had made a huge impact on our participants. Thank you, sir, for creating a meaningful learning environment among our participants. We are very grateful for you, sir, for sharing your PowerPoint presentations with us. Your expertise in teaching has put our minds at ease. We are so grateful to have for your program. On behalf of IQAC and on my own behalf, I thank you, sir, for coming to this session, for coming to our program. We will still collaborate in future. Thank you so much.
Exactly, definitely. Thank you very much. First of all, thank you very much for inviting me. I am in Gujarat and we are conducting at Tamil Nadu. So thank you very much for giving me opportunity to deliver session to such a huge audience. And it is really a great pleasure for me also.
One of the participants has raised her hand. I think she wants to speak something.
Yeah. Amit Kumar
Reddy, sorry. Amit Kumar Reddy, are you ready to speak? Or we can end the session?
No, madam, sorry. Okay, thank you.
Okay.
Okay, thank you.
Okay,
Thank you
madam.
so much, sir.
Thank you.